Hello and welcome to the fourth annual HashiTalks Africa. It's a pleasure to be here. My name is Rob Barnes. I'm one of your MCs today, also known as DevOps Rob. I'm joined with my fellow co-MC, Ilari. Ilari, do you want to say hi to the audience?
Hello, everybody. I'm Larry.
Awesome.
Larry Ayadibi.
Thank you so much for joining us. Now, it's going to be a fun-packed event. If this is the first time you're joining us, HashiTalks Africa is a regional live stream event we do every single year, specifically focused on the continent of Africa, where we bring our tech stories, especially the HashiCorp tech stories, to the wider African audience. This is live streamed on YouTube and LinkedIn. So wherever you're joining us from, we are happy to have you here. And I'm really looking forward to what we have to show you today. But before we get into all of that, Ilari, do you want to tell the audience about the code of conduct?
Yes. First of all, if you have questions, if you have comments, you can interact with us in the chat. And as you do, you have to mind the code of conduct. In general, be welcoming, inclusive, friendly, patient, be considerate, be respectful, and professional. The community guidelines, the link to that is just below the screen there. So thank you very much. You can review the code of conduct. And with that, let's get started. So who do we have next? Do you have
Awesome. So our first speakers, we're giving you two for the price of one. We have two speakers coming in from Nigeria, the west of Africa. We have Jibril, who's a software engineer, and we have Great, who is a site reliability engineer or infrastructure engineer. They're going to talk to us about chaos to consistency, building reliable environments with Packer and Terraform. So really looking forward to this one. Take it away.
All right. Can everyone hear me okay? Anyways, welcome everyone. Thanks for tuning in from wherever you are. My name is Jibril Oyetunji, and the title of this session is From Chaos to Consistency, Building Reliable Environments with Packer and Terraform. Well, this talk was born out of some of the frustrations that Great and I both faced at work when we were trying to build environments in our respective jobs, and we realized we were having similar problems. So we did the logical thing and we came together and made a talk out of it. So, like I said, I'm Jibril Oyetunji, an independent software engineer. Fancy way of saying I'm unemployed at the moment. And I'm joined by Great. He's an infrastructure engineer at Gala Games. So he'll be telling you a little bit more about himself during the demo. So to give you a bit more context about the talk, first we have to start at the beginning. And in the beginning, there was chaos. When we say chaos, we mean there's a lot to unpack when we say chaos because our environments were not exactly consistent, nor were they. We couldn't confidently say that when we deploy this, it's going to behave as we expect. So the area of inconsistency for us, aka pre-configuration management, there was little to no documentation. Version controlling was non-existent. Not that there were no manifests in Git, but the ones we were each using to deploy the infrastructure was not version controlled. How to reproduce, again, inconsistency because the existing infrastructure doesn't match up to the code that existed. How to reproduce, if it's inconsistent, it's really hard to reproduce. Automation, yeah, good luck with that. Is it deployed manually? Was there a script? And no, neither of us really knew. For me, there was actually no automation at all, so which was really bad. And for Great, I'm not sure what kind of automation was in place, but I think we both agree that the automation was really hard. And how do you scale that? Add more people to the team, or what happens when someone leaves the company, or what happens when, in my case, when I leave? So yeah, this was how inconsistent our environments were. So where do we go from here? Well, the solution was Terraform and Packer. I think I speak for both of us when I say it's default to reach for any of these tools when we had these sort of problems. So you're probably going to hear a lot more about these tools in the sessions to come, but I'm going to give you a quick elevator pitch on what Terraform is. Terraform is an infrastructure as code tool that allows you to define and provision your infrastructure in a declarative way. Declarative meaning you define the desired state rather than the steps to get to the desired state. It provides a common language for teams to communicate about infrastructure. A common language being HashiCorp configuration language. Everyone on the infrastructure team can agree that this is what we use to define our infrastructure, and this is how we go about it. Terraform allows you to manage your infrastructure in a consistent way, which is exactly why it's almost default at this point. It provides state management tools that allows you to reliably deploy your infrastructure. And now that we have a common language that we can use to define this infrastructure, we can also put this into Git. Moving along, we have Packer as well. So Packer is a tool that allows you to create machine images for multiple platforms from a single source, and it allows you to build machine images consistently. Again, these tools tie so nicely into like what we're trying to say here, which is reliably deploying and building your infrastructure, so that what we write and what we deploy are consistent each time. And this is why we selected these tools. And I have a small example of what a Packer configuration looks like. So Great will be telling more about that in the demo to come. So does Terraform plus Packer equals magic or consistency? Well, yes, but actually no. The manner in which you leverage these tools will determine how much benefit you can get from them. And we have a few points a few points that we'd like to share and how we achieved reliable environments. The first being consistency is key to success. So as I explained earlier, Terraform and Packer both allow you to reliably and reproducibly build infrastructure. Reducing the number of manual interventions you have in your build process would go a long way into determining how consistent your environments can be. I recognize this is different for everyone, as no two environments are the same, which is why I said reduce the number of manual interventions, because this can look different for any environment. Building intuitive CI/CD pipelines. This is also related to the point of reducing the number of manual interventions. CI/CD is to help automate the deployment of things, and when your CI/CD pipelines are intuitive, there's a higher chance that people would be more encouraged to push to Git or wherever your CI is running. If your CI pipelines are hard to use, nobody really wants to push something because they're scared that they might break the CI, or it's going to be hard to see their changes reflected. Automate everything you can. Again, this can look different for everyone, but as much as possible, you should try and automate anything you can, and document everything you can. Document everything you can't automate, and also document everything you can. Again, if I leave the company, what happens to the infrastructure I've built? Sure, it's running now, but if someone else comes along, wants to make a change, or even tries to understand what's going on, it's going to be hard, and this is not good for consistency in the long term, because they might make a change, they might not document it themselves, or they do something that wasn't as intended. So documentation is actually a really huge part of being able to reliably deploy and produce infrastructure. So with that being said, it's time for the demo. So I would hand it over to Great at this point to show us what our Packer and Terraform looks like.
Okay. Hello. Hi everyone. My name is Great, and I'm the engineer team at games, and yeah, I'm giving a demo on this stuff. So yeah, we'll just go straight ahead. So I'll just get to the code and um, try to explain a few things. So yeah, like in the introduction previously, we had an introduction to what Packer looks like. So that is where I'm going to start from. In this images folder, we have the template.json, which is a Packer definition file. Packer is like a tool to build machine images that could be used across platforms. So building machine images with Packer, you have the builder section, which uses a source AMI and and then you have which uses a source AMI, and you have the region defined the AMI to be used, and also some configurations here. It also specifies the EC2 instance type and also the SSH name to use. So when these AMIs are built, they are defined with a name. So yeah, we define this AMI as HashiTalks Africa, and also added a timestamp to it. Then we also have the provisional section where we are copying this app directory. Yeah, I'll come to this app. We're copying this app directory into the machine image in this destination home user, and we also have the shell which executes the Packer script. So yeah, I'm going to come to this boot. Yeah, let's look at our sample application. We just have something very simple that looks like what goes on day to day. Because you have a simple app to create entries, get the entries, and also get the entries. So yeah, this code is available on the repo, so you can just have a look at what this simple app do, and also use the SQLite DB. So yeah, let's have a look at the Packer SH5. By installing this is a Golang app, so by installing Golang, we're building the Golang app, putting it into the local directory, and also um, creating a system MD, a system um, MD file to like put it to start the application really quick on startup. So yeah, let's talk about the advantages of using Packer. So with all these steps are like kind of pre-configured. So this means that any failure, we get to see any failure before it actually happens. So we get to see any failure before it actually goes to deployment. That's one reason I like Packer a lot, because just like continuous integration, we have a really good feedback on what might happen before we deploy. So I'll just give a sample of what a Packer output is. This takes a lot of time. It takes some time. This build was 9 minutes, 22 seconds. So I had to build it before the demo. So yeah, these are the steps. These are the steps here. It does the provisioning with the shell scripts. Does all we say, install Golang, install the rest, put everything into place, and create the system ND service, and the rest of all that. All these are done like pre-configured. All we just have to do is to deploy this machine image, and we get exactly what we want. We get the application running. So let's take note of this AMI name, AMI 06. It ends with a tray 5. Um, so yeah, then we could also talk about Terraform. So Terraform is um, an IAC, infrastructure as code tool, that allows us to deploy resources to different cloud environments, different Docker, a lot of environments. So Terraform works by using providers. For this demo, we're using the AWS provider. Um, right here, we define a security group. So this security group is opening port 8080 for Ingress, and also port 80 for Ingress, the HTTP ports. And also we have the SSH. So just in case we need to SSH into the instance, and we also have the egress defined. So remember that we named our we built our Packer image with this AMI name. So we are just using a data script here to look for the most recent AMI with this name. So it checks the timestamp and it gets the AMI with this name. And we have this section here which deploys the AMI. The instance type is defined, the key name, and the rest of all this is defined here. So why don't we leave it off and try to see how Terraform helps us in this case. So we could just run a Terraform plan. Okay, so I'll just ls, so you see that these files are here. The reason you see a TF state file and a TF state backup file here is because I had run this program before, like before the demo. Um, Terraform creates this file. So on the normal day, you have to run Terraform init on a fresh repo, but I don't have to run that one because I've done that beforehand. So to just run the Terraform apply or Terraform plan, so we see beforehand what is going to happen. So expectedly, what we are watching out is to see Terraform deploy this AMI that was built by Packer. So this AMI here matches this AMI name here. So that is great. So we could just go ahead and run Terraform apply. So we say yes. So now, what Terraform is doing now is kind of creating the resources, it's creating the security group, and also creating the app instance. So, like I said before, one why I really like using Packer is on a normal day, okay, just put these scripts, put all these operations into your user data file, into user data. And what user data does is that it runs on init. Once the machine is deployed, the user data runs, and that could take minutes, hours. Just imagine an application that has a lot of dependencies. That could take minutes and hours for like this application to be ready. That is for readiness. But with Packer, we could just bundle, big everything beforehand. All we just have to do is to just deploy that AMI, and we have our application starting up immediately. So we just have a look at this. Okay, so this is deployed now. Two resources are there, zero change, zero destroyed. So we could have a look at the app that was deployed. Um, US is one. Oh, I'm on US is two. So we just have to change the region. Uh, quick enough, how is this not coming up very fast? Okay, so yeah, we have this app server deployed. It's still initializing, and you can see that this application is ready because it has already deployed to the AMI. So we could confirm to see which AMI. Remember, this ended with 335, so it has deployed this AMI. So why don't we test the app? I just use Postman to test the app and see. Yeah, because it was start to test the app. Replace this here. So right now we have zero entries. Um, why don't we put an entry? Okay, so we say create. That was quite fast, right? Like getting our app ready. So we say entries. We should get all the entries. Yeah, this is a list of my favorite rappers, hip hop rappers. So it gets the list of all that. So yeah, so as a recap, as part of a recap of what we just did here. So we use IAC. IAC is ensure that we have a reproducible and consistent environment. We could also put our ICs also make sure that we could also put our infrastructure as code into version control like it to ensure that we have different versions and to ensure that we are consistent with what we are building. I will also use Packer. Packer is a tool that create machine images and does the whole pre-configuration beforehand. All we just have to do is to deploy that AMI and a machine image or AMI and to make sure that our applications start up really quickly. So these are some ways to build really consistent infrastructures with this boot tooling. So yeah, that's the end of the demo, and I'll look forward to your questions. Um,
All right then. Thank you very much. So with that said, that's the end of the session. But a few things before we go. If you are looking for the links to the slides and the code, they will be at these URLs on screen. You can find me at Syntax Error on the Bird app, same with Grid, and our respective emails are in the slide on screen currently. But yeah, as a final note, again, the idea here is being able to reduce the number of surprises you have when you deploy your infrastructure. And our choice of tools were Terraform and Packer in this case, but it might look different for you. So the idea again is being able to reduce the number of surprises by leveraging tools that would give you this kind of output. And again, whenever you build infrastructure, try and write some documentation just so the new guy, whoever it is, would not have to scramble around trying to figure out what's going on. And in the long run, you can save people a lot of pain. So thank you very much and enjoy the rest of the talks.
okay, thank you very much, too. And sure, enjoy the rest of the talks. See you soon. Bye.
Bye.
Okay, so thank you very much, Jibril and Great, for that talk on building, of course, reliable systems. I agree that consistency is key to building reliable systems. Thank you once again. And please, if you have questions, you can interact with us in the chat on LinkedIn, on YouTube as well. And with that, we'll have the next speaker. So, Rob, do you want to introduce the next speaker?
Absolutely. Before I do, I just want to plug this new book. I'm not sure if you can see that in the camera. The Best Kept Secrets of HashiCorp Vault. It's a book that Brian Krausen, who's one of our HashiCorp ambassadors, has released recently. It's basically a collection of practical tips from the HashiCorp community. I myself actually have written a chapter in this book, as well as some other really gifted people. So we'll place a link at the bottom of the screen or in the chat for that. All proceeds from sales of this book are going to be donated to a charity. As soon as it's a community book, you can get it on a Kindle, you can get the paperback version, whatever you like. But yeah, it's a really good book. I'm going through it, reading some other people's practical tips, and someone who's been using Vault since 2016, 2017. Even I'm learning quite a bit. So the Best Kept Secrets of HashiCorp Vault. Yeah, go get your copy. But let's introduce our next speaker. So we have Corne, who is joining us to discuss scaling your startup with HashiCorp Terraform. I'm really looking forward to this. So over to you, Corne.
Cornay, you are on mute.
Right.
Better.
Hi, guys.
Thank you.
Perfect. Thanks. Hi, guys. Thanks for the introduction. I'm Cornay Bester. I'm currently working for a startup that's based in Germany, but I'm working from beautiful Cape Town today. And today it's not a technical demo, so I'll jump over just maybe a short introduction to myself. And then I'm actually going to talk about some of my experiences over the last 10 years that I've been working in cloud. And hopefully it's not deaf by slides. I do have a quick show in the end just about some structure, how we do our Terraform today. But otherwise, this is mostly slides, and I'll talk through them. And then also in the end, I've got an option for like Q&A if there are. Right, so just a little bit of background about my journey. I've been working in IT for more than 20 years. Started off in telecommunications, but around the financial services space, doing basically low latency stock market information to brokers and banks. And then over the years, basically organically grow. I even started before the internet was a thing. So technology evolved, computing evolved. So I kept sort of organic growth in my career and keep up with infrastructure, but always been very close to the hardware, the servers and the networking switches. And also this why this talk is around Terraform and sort of my passion for networking and connecting things. I'll go in later to sort of the later companies. After 13 years in telecoms and financial services, I basically moved to two startups. And most of the talk will be, after the two startups, also I worked for a small medium enterprise that was moving their on-prem stuff to the cloud and rebuilding that sort of for more modern era. So that's roughly my background. The talk is not going to be a tech deep dive. I'm not going to show code or Terraform. This is purely around my experiences with in the evolution of infrastructure as code over the last 10 years, and also multi-cloud and across different industries. Then also just added that some working knowledge of Terraform would be useful, but it's not essential. And also like cloud vendors like Azure, AWS, GCP, just some of the terms I refer to. Right, so roughly about 10 years ago, I joined a small medium enterprise after my initial telecoms career, and we were busy in the analytics space after financial services trades happened, like on stock markets. And the company were hosting a lot of these services as a SaaS solution on premise, and it was difficult to scale. It always had problems. There was compute problems, and then the cloud also became sort of more prominent. People were starting to adopt it, and our business made a decision. They want to rebuild our on-prem SaaS location services, for the cloud. And we started, I was based in Cape Town at the time still. A team in Cape Town actually started to experiment with Amazon back at the time. I, at that stage, had a lot of networking and operational knowledge, and I actually got involved with the team starting to experiment on Amazon. And a lot of this back then was, I'm talking 2013 roughly here, was still very infrastructure as code was not a big thing, even though CloudFormation was available. It was still JSON based. I basically got my intro into cloud there. Start playing with things like anyone else, do some click in the UI and you provision infrastructure and actually see the beauty of being able to provision stuff on demand, just delete it. Also from a business side, it looked like cloud will solve all the problems. It's like there's like limitless capacity. It's on demand. You can take advantage of cost. You don't need to have all these upfront costs. Then another thing, came into play, and that's because we were in financial services, there's regulatory compliance. So we had to be, because we work with financial services and specifically trade information. And it was also, I have to add here, this company was based in the UK with offices in South Africa. In the UK, they head office, and also big data centers in North America, in Canada. So we had 3 on-prem data centers, and we had different services and products deployed on-prem, and we wanted to take and rebuild this for cloud. But the business was also very like afraid with like technology. Can you be secure in the cloud? Can you tick all these ISO and SOX compliance requirements? So that was something where I'll also get involved with my background and like stuff I've done on premise. And I'll continue into sort of that space. That's also where I got involved in cloud first, because I have this history with making things sort of compliant to match regulatory stuff. And this is where my cloud journey sort of started. They didn't have like landing zone concepts that we're familiar with today. This is something relatively new, say that's been around the last 4 years. So back then, it was still a lot of manual work. I started off like anyone else with what some people jokingly call infrastructure as click, where you just click on the UI, you provision VNets or VPCs, you create security groups, internet gateways. So a very manual way of doing things. I also, because I started working with multiple teams, the team in Cape Town started with Amazon, but we had a product development team in the UK that also wanted to break into the cloud, but they were all Microsoft stack and they wanted to go to Azure. So I started working actually on both these clouds, helping these teams with connecting cloud resources to on-prem databases. Still a lot of manual work, doing things in the UI, not completely understanding how cloud works yet, because on-prem was all manual. Yes, there was some automation, but it's still in the cloud, everything is foreign. I also started with CloudFormation templates to start it, because of all these manual work. Try to look at some automation and get a feeling for CloudFormation. It was quite painful because it was all JSON based back then. Azure had a completely different approach. You had to use ARM templates, which is basically PowerShell scripts, and they also don't have a state concept. So you would provision stuff need to change. You'll have to delete them again. You can't add or modify them. So there was quite a bunch of limitations with both ARM and CloudFormation. Then also another challenge was because we're multi-cloud, we needed to have multiple accounts for development and production resources, multiple environment like production, dev, test, and it's cross-cloud, and we've got on-premise. It's like these tools just doesn't scale. It doesn't help to have a different tool for every cloud and every product, and that's where Terraform sort of came in. I first got because I not struggled with CloudFormation, but because you didn't have a unified place where you can manage all your compliance requirements and security rules. Terraform was very cool for me back in the day, and was also now you have a single tool and you can work on both Amazon and Azure, and possibly on-prem. VMware, because we were big on VMware as well, they started adding providers. So I got involved with building landing zones before landing zones was a thing today. Basically, it's doing these standard account setups. We were doing things like CloudTrail and config across multiple Amazon accounts, doing observability integration, central lock integration. So I think at the time we had 5 different Azure accounts, 9 different Amazon accounts on-prem, but we had a central lock ingestion solution, and we wanted to aggregate all the locks in the company in a single place. So we're doing a lot of these landing zone standard tooling or shared tooling, also hybrid networking with VPNs and interconnects between cloud and on-prem, because we moved quite a lot of data around. And then also the requirement came for, again, compliance and regulatory, to have Active Directory, it's basically single sign-on access across all these resources. So yeah, Terraform basically empowered us to start automating a lot of these things, because we cookie cut the recipe across these accounts, even cross cloud. And so it solved a lot of regulatory and checks. And when you get audited, you can say you've got all these things in place in the financial services industry. So very, very good start of my career, evaluated different tools, ended up with Terraform. So that sort of wraps up the first. I spent 7 years with this small medium enterprise, but only the last 4 or 5 of them were around sort of cloud and scaling cloud, making things standard. was not so much involved with the software engineering or development process at the time, even though I worked with teams and we tried to get standards going, because we also had development teams in Italy, in the UK, in South Africa, and they all worked on different stacks. So I worked as like a consultant, and my team, we grown a lot later to like a 3-man team. We became sort of this first DevOps team in the company that provide these landing zones for all the teams, and then they can build additional services on top of this. Then I actually got the opportunity to join a startup, and I've never worked in startup because my first part of my career was corporate, and then I worked small medium enterprise. And I loved cloud just because my career organically took me to a place where you can now provision infrastructure as code. And I thought, yeah, this would be fun. So I left the financial services industry completely, and I joined a public safety startup that was based in the US, but also a development center, and it actually originated in South Africa. That's also why I sort of call my main topic A Tale of Three Continents, because my experience span like these 3 continents, North America, Africa, and Europe, even though our customers is global. So what was interesting when I joined this startup is they were post a Series A funding, so kind of already they've had a market fit, and they were ready to scale to sort of the next big thing. They had large clients in the US already signed up, but also because they're in public safety, that is like 911 systems in the US. So when people phone for emergencies. So the startup was basically using modern mapping technology like Uber, and they were basically to find people. So very high availability systems needed to be required, very high transactional system, because there's obviously a lot of calls happening in a day. And because it's government clients, so public safety is part of like the government portfolio in America, they also have like quite strict regulatory compliance around where data lives. It's not allowed to leave the US. There's also, what was interesting is Azure had at the time, and I think AWS as well, they've got what they call sovereign clouds. So you've got a public cloud, which anyone can use, and then sovereign clouds, you need to prove you work with government clients. Another interesting, when I joined the startup, is they're very performance and latency sensitive. It's like, because it's in a 911 space, if someone phone and they got a heart attack, seconds matter, and you can't wait like 5 minutes for something to process in telephony systems, because the startup built basically a platform to find people and then dispatch the correct response to that. So latency performance is very big requirement from the business. And then they needed to scale to multiple regions and public and sovereign clouds, because they've actually had customers in both these. So one of the big requirements here was also to get infrastructure as close as possible to the end users. For example, the state of California, the whole state was a big customer, but the closest Azure data center was actually in Arizona in the US. So these things start to matter when you've got like millisecond latency requirements. You need to co-locate sort of your resources close to your customers. But then we also started getting more customers in other states. We had Kansas and South Carolina, North Carolina. So we actually had to break into multiple states in the US. So we started hosting in Virginia, we had in Arizona, and there was also data sovereignty limitations. So like this Arizona state, for example, don't allow the data to leave actually outside the state. So for example, if there wasn't a Azure data center in Arizona, you couldn't host there. You'll have to have some other solution. So luckily, some states are less strict on this, other states are more. So it's very similar to like data is not allowed to leave the European Union and move to the US and vice versa. So Terraform again helped us here basically scale. So we've created like this large template declaration of all our resources. And each region have roughly about 70 different ones. And that being app services for those that work with Arizona, with event hubs, AKS clusters, storage. So Terraform allowed us basically to scale and break into new states by using this cookie cutter approach. We've got this defined template of all the resources we need, and we can just basically pick this region, parameterize it, add some customizations depending on the size and the requirement of the state, and provision it as closely as possible to the customers. We had also some other cases around security testing because we're in government, we needed to do some testing, and also for performance, so quality testing, QA, and also for performance testing to make sure the product's performance is. And this is where Terraform is also useful to basically create resources. We can set up basically a complete stack, do some testing, tear it down, and you don't have to have something running all the time. Still on this startup I joined, it's in North America. So I mentioned about Terraform that came to the rescue. We managed, and this is just, I'm going slightly more into how we use Terraform. We stored actually our state in storage accounts back then, which is a Azure type of S3 service combined with EFS. We had multiple service repos. So we had actually like a definition for all our app services, and we had a definition of all our storage. So we separated basically by service, not by product per se. And we also later started using some Terraform Cloud, but in a very early phase. Then I'll get back to some of the details a bit later on like sort of structuring repos and Terraform code, because that's also a very opinionated thing and it differs from company to company. So I'll just share some of my experiences a bit later. First off, we started with Azure. Basically, every Terraform resources in Azure was Terraformed. We later added Datadog monitors because we had to repeat a lot of things. And that's obviously one of the things Terraform solves, is you have got repeatability for your infrastructure, and you also got this complete definition, and you can actually version your infrastructure of what it should look like. We added lock ingestion resources later that was like central to the company, and even Cloudflare we started terraforming. So roughly, I think 4 different vendors terraformed at the time, but also in various phases. Sometimes, and I'll speak later a bit as well, it doesn't make sense to terraform something if there's just a few changes necessary. But if you have to repeat the same config across 20 different regions and different customers, it becomes sort of a requirement. Roughly as well, so we didn't use workspaces back then. We used basically Terraform vars files, for those that's familiar with it, and basically have a single template of what our infrastructure looks like, and then any differences we defined in a Terraform vars file, be it the region, be it government cloud. Just also sharing a bit here, what was interesting is that we ran into problems where the sovereign cloud, the government one in the US, actually was lagging. The APIs was lagging the public cloud. So you could do basically development on the public cloud, and by the time you want to release a new infrastructure, say version 2 of an API gateway, it's not available in Gov, and you need to basically wait 5 to 6 months for this feature to be available. So just something to be aware of. Sometimes there's and even you see this in Amazon today, it's become less over the last couple of years, where they'll launch new services first in, say, Virginia in the US, and a couple of weeks or even months later, you'll see it roll out to other regions. Some regions is faster than others, but there's always like a delay when new stuff is released. Right, then just moving on to keeping note of the time, we moved to another startup. One of the big reasons why I left was I was missing Amazon. Amazon was sort of my first love. I started my cloud journey with Amazon, and I prefer Amazon above Azure, even though both clouds got their strength. So I got the opportunity to join another industry and another startup, which was actually in the logistics space. So first off, obviously, my career started in financial services, then I was public safety, and now logistics, and also apply using Terraform knowledge and tooling across all these, because they're not really tied to industry. You can solve the same problems. Just a little bit about the startup. They post Series B funding, so slightly more mature than the other one of where they are in their business. And we also have this, what we call streamlined teams, is basically you build it, you run it approach, and also share nothing. So this is a very new sort of modern paradigm of building software and moving fast. So I joined there a cloud platform team as a cloud team lead. And we basically now today provide a developer platform to the enablement of our development teams. So we even take Terraform and abstract it further and Kubernetes, where we, instead of my previous startup, I was more customer focused, or the tooling we do for our customer. I've also switched slightly to provide more internal services today. We still have our development teams, which is our customers, but also our external customers using our marketplace, because that's what we have in the logistics industry. So we have this requirement that we basically have to manage or allow developers to create test environments on demand, to test features, to move fast. So today, just a quick recap, we've got 3 EKS clusters in multiple Amazon accounts. We've got 3 production-like environments and then 20 plus test environments. So our product teams use these test environments to deploy versions of their code, to test a new feature. And if they're done, it can be promoted to production. So we're not sharing test environments. Each team has got a unique environment, and they're also responsible for the data and data migrations, everything around this. So we do a lot of empowering developers to move fast. So our estate has grown quite. We've got more than 120 RDS, Aurora MySQL databases. We've got Amazon message queue clusters, lots of S3 buckets. So all our policies in IAM is used by Terraform. So quite a next evolution of how we roll out and manage everything with Terraform. Just moving on as well, just to be conscious of the time. Also Terraform. So when I started, there was some Terraform. I built out a team of 5 people now today, and quite a bunch of smart engineers. And they also come from different industries, very DevOps background. So we actually taking Terraform to a whole new level. We're also using Terraform Cloud now completely. So all our state is stored in Terraform Cloud, not S3 buckets anymore. We use Terraform Cloud workspaces. So we separate our environments by Terraform workspaces. And we also started to do continuous deployment in some of these via workflows, which I'll also talk about. Just around the vendors we manage with Terraform today. So we even do Auth0. We added Confluent Cloud to Terraform. We use Cloudflare, Snowflake. So we use Terraform basically to provide this integration and development platforms all with Terraform today. Couple it strongly with Terraform Cloud. The workflows we also integrated with GitLab. So we use GitLab. We use pre-commit hooks to basically validate Terraform code. We look for security vulnerabilities. It triggers an automatic pipeline in GitLab that actually does CI integration. So it checks, validate the plan again. It runs a Terraform Cloud plan, provides you with a list of changes. If it passes without any errors, you get a green tick in GitLab. And then we still have a gated apply. So we still need to verify the plan before we actually apply the infrastructure changes today. Just be very conscious of time. What's next? We're shifting even more left. So we're providing the self-service where teams can modify our infrastructure as code repos, and they can provision their own Elastic registries, their own service accounts, their own S3 buckets. We provide some standardized modules of S3 and what RDS instances look like, and they can provision this on the fly. Then just I'm going to run through some tips and tricks over the last couple of years, learned. First one, should you automate this? And the question is, sometimes the effort, there's a nice infographic I could share, but I just didn't have the time for the slide. I would always ask the question, what's the problem you're trying to solve? Do you want to scale something? There's so many providers today, you can Terraform every single thing. Sometimes it just doesn't make sense to spend an hour or two to write the infrastructure code. if it's something that's only going to be done once and forgotten. So I would always ask myself, my default is to Terraform all the things, but you should always ask you as well, is the effort you're going to put into it worth it versus some other problems you can solve? Then another tip, read your plans properly. So when Terraform give you a plan, always read the plan very carefully, especially if there's a destroy and a recreating plan. We've been burned a couple of times where you scan too quickly through a plan and then actually you lose data or something unexpected happens. Then treat your infrastructure as code tooling, just as you would other software. Keep your provider binary and your providers up to date. Every month there's a couple of new releases. Keep an eye out for upstream vendor API changes, and then also stay abreast with updates and gotchas. We subscribe to like GitHub provider repos with alerts if there's security updates or breaking changes. Just a good practice as well. Then adapt to your dev team's business, like looking back across all the 3 companies where my cloud journey has been, they each had different requirements. The one was around regulatory compliance and being able to be pass certifications and audits. The other one was around performance and being close to customers. Again, also about where your data lives. These things. And then the latest startup I'm working at is about making development teams move faster. So you got to adapt to your development teams and your business where the requirement is. And your Terraform code will sort of follow that pattern as well. Consider your clients, latency when you pick a region. That's very important. Yes, there's CDNs globally, but sometimes it still matters depending on the product and the industry you are in. Another tip, plan always for global rollout expansion. You might become the next unicorn today. And for that, you need to break into new geographies, continents. So always plan, even though you try to keep things simple, think about the future and that you might become a unicorn. I think every startup wants to become a unicorn. Then also tag all the things. I love tagging. I like grouping things. I know the new Terraform providers even have tagging built in by default. So even if you don't explicitly tag a resource, it will automatically add it for you. It's very useful for cost reporting. So yeah, always tag all of it. Give it a business owner, give it an environment, give it a data life cycle. Then also the KISS principle, which stands for keep it simple, stupid. For those that's familiar with it, basically don't over-engineer. So like there is all these cool things like control tower and account factory. If you're still a startup in the early phases, don't waste sort of time on those things. They can come later if you want to scale, be like a bank and you need to scale to 50 different accounts or 100 different accounts in networks. So I would say don't over-engineer in the beginning. But again, it's depending on the requirements. Separation of concerns. Something I've learned over the years is to not couple networking, and that's IP networking, too tightly with the application. Keep that sort of separate. And that is your VPCs or your VNets in Azure. Manage that from like a global holistic view where you keep proper routing in place. Because sooner or later, these things will need to start talking to each other. And if they on the same Cedar blocks, there's always problems. Just some more tips and tricks around cost. Always use multi-availability zones for high availability if your budget allows. We are facing an issue where some stuff was hand-built on single availability zones, and today they're in production and we need to change them. So it's just the effort to redo on a live database. So yeah, just try to always go for production multi-availability zone for any resources that needs it. Parameterize your instance types and sizes and regions. It gives you flexibility for production and dev test resources. Production obviously need way more powerful compute than normally test environments. So yeah, don't hard code those. Then also watch out for third-party modules that might over-provision. We recently discovered we were using a module from a not an official provider from HashiCorp, and it was basically provisioning net instances in every subnet in all the regions we operate. And in those, we don't even use private subnets because our databases is in a separate VPC. So we've just been paying for something we actually don't use. So just be conscious of, like, when you use third-party modules, actually check what they provision. Then also another tip, enforce Git repo policies. Always have reviewers review changes to production. Sometimes they're very small and something might snug in that affects your whole platform. So always use a second and a third pair of eyes. Don't push to main branch, basically. Then structuring by Terraform source code. So over the years, we've tried different things, and I mentioned it earlier. We group by servers, by product, even by cloud, by vendor. So I've tried a bunch of different things with teams and over the years. And the more recently, we decided we group by vendor and or business unit where it makes sense. And I'll also show a quick structure just after this. And then we use subfolders for different services. And one of the reasons for that is we keep also our state files separate for each of these folders or repos, because it makes it faster. If your state file becomes too big, there's sometimes credentials in these, so you want to be cautious about this. But if you have to run large plans and there's a lot of resources, it just takes time. So over time, this is what we currently do today, and it kind of works well for us. Before I jump to Q&A, I'm just going to share my Visual Studio Code. So this is an example of how we manage our resources today. So we've got a networking. I mentioned that. We separate that. And basically all this is cross-account. And we manage VPC peering here. We manage Route 53 here. We manage, so everything that's cross-account. This is very holistic globally how we do this. We keep that separate from our other Amazon resources. There's no on-prem here, so this is all Amazon Cloud Native. Then all our Datadog stuff we keep separate with modules underneath. So we use Datadog for everything: log aggregation, APM monitoring. All our dashboards is actually defined here as well. Our monitors is managed here. So everything Datadog related we keep here. And it's got its own workspaces. Terraform Cloud's got it, or networking, it's got its own workspaces. Then Amazon, so we grew by vendor. So Datadog vendor, Amazon vendor. We also group by Cloudflare at the bottom. I haven't added Confluent Cloud for now, just as example. But then we'll, like under Amazon, we will have a separate folder for each resource type we use, like EKS, Amazon Message Queue. And each of these would have its own workspace, be it production or not. Sometimes they have sub-modules like RDS. We've got modules for MariaDB, MySQL. We even have Aurora Serverless now. OpenSearch we manage differently. So all these resources we manage sort of on the individual level. EKS, we've slightly changed to using Terraform Cloud private registering now. So we version our EKS modules we use across our clusters. But this is how we structure today, and it works quite well. Also, we've standardized something I can show is our providers. So this looks identical across all the Terraform state we manage. So the tags we use, this is slightly evolved. I can take another one, for example. We basically standardized on this format. So everything that's related to Terraform configuration is in the terraform.tf file. And this looks very identical across all of them. So we keep a Terraform file, we have a locals, a data, but we've stopped using like providers because we configure the Terraform Cloud stuff here, as well as the different providers we use, etc. So yeah, just a view into how we do things today, which we found works well for us. And I'll give opportunity for one or two questions if there are, and we've got time.
All right. Thank you very much, Connie, for sharing your experience. Nothing beats experience, actually. Thanks for sharing that with us. And I see one question here. It says, based on your experience, of course, how does a new provider, you mentioned something about keeping provider updated. So this question from Christopher says, how does keeping provider updated affect existing code? You just want to touch on that quickly?
It sometimes it does. We normally it doesn't. So it depends on what it is. So minor releases, like going from version 1.3 to 1.4, was painless. I've had problems before where going from obviously 11, because I started, I think, pre-version 0.11 to 12 to 13. There was quite a lot of changes in the providers. Oh, sorry, that's a Terraform version, not the providers. The providers actually, we had a recent incident where something changed on the EKS control plane, which broke something. So I would say always test, and not in even a development or in a development platform environment. We also at a place now where we spin up a test cluster or sandbox cluster and even test the provider there before, and which is a like for like to what our production and dev test environments look like, just to make sure it actually works before we promote it, to get an idea. Because we also had cases of where just a small change disrupt the whole, like there's things like the underneath the container D, Docker changes that went into container D. And so there's always so many dependencies. So I would say test before you promote. But it's always good practice, because if you don't do these small incremental changes, then jumping from like 1.3 to 1.7 is even more major. So it's very similar to local software development practices. Try more frequent, smaller updates versus these large, big jumps.
Awesome. Thank you once again, Connie. That was an exciting talk, and we'll see you around. Please feel free to check the YouTube stream. I think there are more questions for you, and you can just do justice to them over there. Thank you very much.
Thanks.
So,
Thanks,
Rob,
guys.
I see we have more talks. Do you want to introduce the next speaker?
We do indeed have more talks. I just want to shout out Gorne for that. That was a fantastic talk, especially from a startup perspective. It's something that often we take this enterprise experience and then think it's the same thing when you go to a startup, but there are economies of scale. So it was really good to hear. But yes, we have another amazing speaker ready and waiting for you. We have Adefemi, who is an innovative software engineer with a proven track record of identifying performance issues and making updates to achieve optimal performance. So that's something almost every high availability platform is going to be looking for. And Adefemi is going to be talking about running Terraform locally using Localstack. So looking forward to it. Over to you.
Can you hear me? Okay, I think I can see my screen now. All right. Thank you so much, Rob and Larry, for the quick introduction. My name is Adefemi Michael, and I work as a DevOps engineer for Swisscom, which is a company based in Switzerland, but I work at the Outpost office from Netherlands. So for today, I'll be speaking on testing with Localstack on Terraform. I'll just be walking us through just 3 basic headlines, and then I'll do a quick demo. So for introduction, I believe Terraform shouldn't be a new thing to be introduced to most of us here, if not everyone. But I'll just run through what Terraform is real quick. So as we all know, Terraform is an infrastructure as code tool. Basically, you define your infrastructure rather than doing a click on AWS console. You basically define your infrastructure using code. Of course, you can either write it in using like HCL, which is HashiCorp language, or you can write it using CDK, whichever you want to write it as a developer. And of course, Terraform is not just the only infrastructure as code tool out there. There's also tool like Pulumi, and there's also Vagrant as well, which can be used to do the same thing. And because Terraform is cloud agnostic, Pulumi is also cloud agnostic. But the interesting thing with Terraform is that, like I said, it's cloud agnostic, so it's not specific to a single cloud provider. So if you learn the language, the HashiCorp language, you can use that to create infrastructure on AWS, create infrastructure on Azure, GCP. Think about whatever you want to create, or you can even write your own provider and create something with it. Yep, I've run through this. What Terraform is open source, so you can also clone this, refactor it the way you want to refactor it in your own organization. Like I said, it also allows users to describe infrastructure resources as code using a declarative configuration language. Yeah. So what is Localstack? I think the first time I had this terminology was actually for an interview for the company I'm working for now. And then they were like, yeah, they have this, they created some sort of resource, step function, S3 buckets, CloudFormation, Lambda, sorry, I say CloudFormation, CloudWatch logs, and Lambda, and they wanted me to deploy it using Localstack. So that was the first time I heard about Localstack, and then I started researching what Localstack is. Apparently, as an engineer, as a software engineer, you must have developed something that you've tested in your environment locally before, maybe an API or something, using Postman. You can easily test your API out, or maybe you are a front-end developer and you deploy your application locally on your environment. Of course, you probably use Google Chrome to sort of like test out your front-end application. But this time is like, how can you test Terraform configuration? And they legitimately said I can use Localstack to make this deployment. And I was shocked how Localstack can actually pick up my Terraform changes, because in my head I was thinking it's going to deploy it to my cloud provider, but apparently everything runs locally on your environment. So at the back, Localstack, you can either install it directly to your system, or you can run it in Docker, which was what I use, and which is what I will use for this demo. And with it, you just create a Docker Compose file, state your parameters, the objects that you'll be using in AWS. I think for now, to the best of my knowledge, Localstack works more preferably with AWS. So maybe for Azure, it might not be the case, but I know they have an enterprise version. So maybe that could work with Azure. But yeah, Localstack is also open source, just like Terraform. And it sort of like provides a way for you to manage your AWS cloud resources locally on your system. And the main purpose of Localstack is for testing. So just like Postman, just like you having an emulator, maybe you're an Android developer or a React Native developer, and you have an Android emulator or Xcode or something that allows you to sort of like write your code and then you see it in an emulator before deploying it to production or something. So that is exactly the main concept of Localstack. And yeah, you might ask, why should I go with Localstack? Because I can easily deploy on my environment. But yeah, I've also seen a memes where there was these two guys sitting, and then there was this other guy that was sitting like he was extremely broke. And then the other guy was asking him, what happened? Why did you get broke? And he said he forgot an EC2 instance that was running. So yeah, so this might be the case for you or not. I've also run into that sort of issue before, where I forgot I had an EKS cluster running, and yeah, that led to some sort of like cost expense on my end. So Localstack is cost effective because you are deploying this locally. You don't have to worry about your running EC2 instance in AWS. You don't have to worry about your running API gateway or something in AWS. You don't have to worry about that. It gives you faster feedback. With faster feedback, you don't have to like go back and forth with deployment. Since everything is run locally in your environment, you get the output in your Docker logs. So you literally see everything that is happening, testing everything out locally in your environment. Also for improved testing as well. So if you are someone that do a lot of iterations or want to, like, you see something, or you develop a new way to write maybe a for each or a for loop or something, or a conditional statement, Localstack can help you with that. So rather than you going back and forth, switching from your AWS console, coming back to your Visual Studio Code or whatever ID you are using, you can easily see everything happening in your terminal. You don't have to go back and forth to AWS console. and also reduce complexity as well. So yeah, I don't know if there are any other tools out there that helps with testing Terraform locally on your environment. But yeah, Localstack help you remove the complexity of thinking of how to manage deployment and all those stuff. So these are like the four reasons why I sort of like saw Localstack interesting. And yeah, I have a quick demo that I would actually love to show us. So basically for the demo, what I'm trying to do is deploying a file to S3, and at the back, once the file lands in S3, it's going to trigger a Lambda function. And basically the Lambda function is not doing anything, it's just loading the file, and then that's just it. So I will switch to my second screen now, and then yeah. So prior to this, let me know if you are good. Okay. Yeah. So prior to this, to this talk, I've created a Docker Compose file. So like I said, I'm running Localstack in Docker. So all this just take is, of course, creating a Docker Compose file, stating your image, which for my image, I call it Localstack. The port that Localstack uses most of the time is 4566. Most of all these environment variables are not needed, but I'm passing them in because I want to see the logs out here. And my Docker host, of course, is Docker. I'm using volumes because I might need some stored file. Because I'm using volumes because I'm pushing a file. I'm pushing this README. I'll be pushing this README file to S3. So I'm just needing volumes in case I delete something or I need my file back or stuff like that. But this is not necessary as well. The most important thing is to have your image and to have your port. That's like the most important thing. And maybe also set your Docker host as well. So what do I have in my main.tf? Like I said, I have a Lambda function. The runtime is Python. I've written the Python code. Like I said, it's basically just downloading the file from S3, process the file, doing nothing than just printing out the data that is in the file. And the file I'll be pushing for now is README, and I think I'll be trying with a file this file.md as well. Yeah, so I have my Lambda function created. I created an S3 bucket. I don't have to worry about the name of the bucket because this is running locally on my system, so I don't have to think about the uniqueness of the name of the bucket. Yeah, for my bucket ACL, I allow it to be public read. I created a notification, like I said, when the file drops into S3 is meant to trigger the Lambda function. So I need something that will notify Lambda that a file has dropped in S3, so which is the S3 bucket notification. Added some permission for Lambda, created a CloudWatch log group just to see if just to see the logs of what is happening in my Lambda function. Added a rule for my function as well, a policy, and a policy attachment. And for my provider.tf, yeah, I can show you this with my access key and my secret key, so you can try this on your system. I'm joking. So yeah, for my provider.tf, I have my access key, so I'm just giving it a random name. This can be any name at all. Think of anything you can ever think of and just put it in there because it's running locally in your system. Secret key and the region as well. Because I'm using CloudWatch, I'm using CloudWatch logs, I'm using IAM Lambda, S3, and STS. So I have to also pass in all these endpoints in my provider.tf. This is because I'm doing it locally on my environment, of course. What else? I've shown you my Lambda function. So like I said, prior to now, I've actually done because I don't want to waste much time, because this Lambda function takes a lot of time to get created. So prior to now, what did I do? We'll scroll up real quick. I did let me open my README. So in my README, I have all the necessary steps that you can use to deploy this stress-free. So in my README, I have a Docker Compose up, which of course you have to have Docker running. I have Docker Compose running in another terminal, which is this. And then, like I said, watch the logs for execution, preload. I mean, this is the amount of time it took on my system for it to load. Of course, it might take less time on your own system. And the next thing is to export your credentials. So like I said, we are deploying this locally, so you don't have to export your AWS. You don't have to use your AWS credentials on this. You can, like I said, you can create whatever in your provider.tf, passing any secret key and access key, which is what I'm also using here as well. And I'm also specifying the region. And then after that, I ran Terraform init. In my second terminal, I ran Terraform init. And then I ran Terraform plan, which is somewhere here, just to show me what I'm deploying. And then I ran Terraform apply. I'm just passing the auto approve flag because, yeah, I don't want to type in yes or no or whatever, because I know what I'm writing is correct. So yeah. And then, yeah, so with Terraform apply, it creates the resources, as you can see as the output here. So 9 resources got created, which is the function, the policy, the role, the S3 bucket, the notification, and the CloudWatch log group as well. So the first thing I'll be doing is I'll be pushing this README file that I have here. This README file, I'll be pushing it to the bucket that I have created. And let's see if this bucket name is actually correct. So the bucket name is what? Test bucket 070. And I have test bucket 070 here using my S3 URL. So I'll just copy and paste this, and let's see what happens. And if you look at the other terminal where Docker Compose is running, while this is getting pushed, you will see an output here about determining the main container IP, and then here the file has been uploaded to S3 bucket. Now let's run an AWS command that lists the file in our S3 bucket. So this just lists the file in S3 bucket, and so you can see there's a README file in S3 bucket, which was created today, some few minutes ago. And if you look at your Docker Compose, you of course see an output of the command you just ran. And like I said, we have an S3 notification, right, that triggers when a file, so we have a Lambda function that gets triggered when a file drop into our S3 bucket. Because I pushed the file, this is the output of what you are seeing, because of course something hits the S3 bucket and then triggers the Lambda function. And of course, it's created a log group, log stream, because it's a put log event. Something is hitting the S3 bucket. You can also see the response code out here as well. And for the last command I ran, which is listing S3, you can see the response code here as well. So the next thing I have in my README for this is to actually delete the file from S3 bucket. But before we delete the file, let's check the log groups. So for this, let's describe the log group so I can grab out the name of the log group. So for the log groups, I need the log group name, which is AWS S3 Lambda, which I think I have passed here. Then I need the log stream name as well, and which will be, sorry, I need to describe the stream. So this is showing me the log group name. So I need to describe the log stream. Yeah. And if you look at my Docker Compose file as well, you can see a command, like a Docker logs, that shows that I ran a describe log group command. So let's grab the stream of the log stream name. Yeah, so this is the log stream name. This is the value I need to pass that in here. Yep. And then the next thing is for us to actually get log events to see what is going on in our, to see what happened with the Lambda function rewards, which I think is going to error out some stuff. But let's see. Yeah, so if you look at something happened, a request started, but this function ran, but there was some error in a particular line, as you can see here. Yeah, so there was an error that happened at this particular line, forbidden file, blah, blah, blah. But yeah, the most important thing is it triggered our Lambda, and then we can see the event that, of course, a file dropped into S3, triggered the Lambda, and yeah, something happened in between, which make the Lambda function to fail. But whatever happened, this is not a coding session. This is a Terraform session. So yeah, so the whole goal of cloud of Localstack, like I've pointed out, is just for you to run this stuff locally. Imagine if I was doing this on AWS, I was deploying this to AWS. That means I will have to go to AWS to check CloudWatch, see my logs, then come back to my terminal to fix the error, and then deploy again, check AWS to see what is going on, come back to my terminal to fix the error. So it's more or less like a back and forth, which is the fast feedback that I mentioned in one of the use cases of Localstack. So yeah, with this, I was able to deploy a Terraform configuration to locally to my system, and yeah, we were able to push a file to S3 bucket. We were able to see the file. We were able to grab the name of the logs because it created the log group name because it created a CloudWatch logs. We were also able to grab the log stream name as well. And we were able to see that, oh, yes, the Lambda function worked. So one last thing I would like to show, one last magic before we leave, is to actually delete the file that we have in S3 bucket. So I will use this to delete this file. And then this should run the delete command. Of course, in our logs, you will see that the delete command was run. And then I would push this file.md to S3, then I will try to run a Terraform destroy. And the whole goal of doing this is just to tell you that this stuff works just the way as how you will deploy to AWS. Localstack works the same way, how you will deploy to your cloud provider. So if I run Terraform, if I push a file to S3 and I run Terraform destroy, of course, it's not going to destroy the bucket. And why? Because there's a file there. There's an object in S3, so you need to delete the object before you can be able to delete the bucket. So I'll show us that just to, do my last magic before I leave the call. File.md, and then let's copy this file. Let's list what is in our bucket. Yeah, we have file.md in our bucket, and here as well you will see the list command in the Docker logs output. And then let's run a Terraform destroy. Hopefully this goes quickly. But of course, the whole concept is Terraform destroy will fail. And why will it fail? Because we have a file in our S3 bucket. Yep, so it has started. Come on. Yeah, because we have a file in our bucket, and then let's watch out for what is going to happen in our Docker logs as well. So Docker logs also, as you can see, is running the delete IAM role, running the delete Lambda function, running the delete policy, running the delete bucket. And if you look at the output here, it's saying bucket not empty. Now, if you go back to our Terraform command, of course, it's saying deleting bucket, blah, blah, blah. The bucket you try to delete is not empty. So this works the same way, just how you deploy to any of your cloud provider. And if you try deleting S3 bucket that has an object, of course, you won't be able to delete it. So, but the most interesting part about all this is that I don't have to worry about deleting anything. I don't have to worry about my file in S3 bucket. I can literally just terminate, stop Docker, stop running the container, and then I'm good. Everything is cleaned. So if I do a Ctrl+C here, it deletes everything from my environment. So I don't have to bother about having a resource that is running somewhere, or having a file in S3 buckets or something. I don't have to think about paying AWS at the end of the month. I don't have to put all those in my head because this is local to my system. So I'll just terminate this, and of course, it's going to clean up everything and stop the container. So yeah, that is the quick demo. And let's go back to the slide. So, yeah. So overall, the whole concept of Localstack is just for you to run Terraform. And also, if you are someone that is, if you are new to using Terraform or to using infrastructure as code, or to using the cloud as well, I think the first thing that should be at the back of your mind is cost. With Localstack, you don't have to worry about cost. It helps with cost savings, like I wrote here, faster feedback, just what we saw. And then portability as well. So if you have Docker running in your system, maybe you don't have Docker, any container orchestration tool that you have running in your system will definitely work with Localstack. And yeah, this comes to the end of my talk. Thank you.
Absolutely amazing talk from Adefemi Michael there. Thank you very much for that one. I'm sure the audience enjoyed it as much as I did. I saw a comment from YouTube and somebody was, saying, how come I haven't heard about Localstack before? All right, so this solves a lot of problem. I can relate with this stuff. Thank you so much again, Adefemi Michael, for that one. And yeah, we have more exciting talks coming ahead. And Rob, please just give us that one.
Fantastic. And yeah, I'm so glad you pulled up that comment on I think it was YouTube, because I saw it and I said shared emotions, because I've done most of my work with Azure and GCP, not as much with AWS. And I just thought, where has this been all of my career? But yeah, thank you so much for that. So let's move on to our next speaker. We have Bjorn joining us from a sunny but cold Cape Town, South Africa. Bjorn is a data architect. He works at an organization called cloudandthings.io. And Bjorn's going to be talking to us today about automating infrastructure as code testing with Terraform, AWS, and Python. So over to you, Bjorn.
Hello and welcome. Thank you for joining this HashiTalk on automated infrastructure as code testing with Terraform, AWS, and Python. First, a little bit about me, your speaker, before we begin. My name is Bjorn Olsen, and I'm the head of data engineering at cloudandthings.io. We are based in Cape Town. As you can see from the slide, I am passionate about big data, software development, the cloud, and things. I've worked in the data space for over 10 years, primarily designing and developing big data solutions, both on-premise and in AWS cloud, with a focus on data lakes. I may seem like a data guy, but I've had the opportunity to work with Terraform for the last 5 years or so. So I'm familiar with some of the challenges around infrastructure as code, particularly how and why might we want to test infrastructure. I think most engineers would say that testing is important, but often we don't do enough of it. Let's therefore start our discussion by considering some motivation for implementing tests. Now, there are many reasons for testing and many things that you may want to test. Here I put down some guidance. What do I think are some of the main reasons to write tests? This will help us decide what to focus our limited resources on when we write our tests. Primarily, we want to produce high-quality code. There are many dimensions to quality, so let's talk about some that I think are important. Firstly, is our customer or user satisfied with the infrastructure that our code produces? Is it easy to pick up and use? Does it cover their requirements? I've realized that a good way to ensure these things are in place is if we have examples that demonstrate to our user how to implement the infrastructure, as well as tests to ensure that the examples actually work. Is the infrastructure dependable and repeatable? Does it do what it says on the tin? How does the customer know it's true? Well, testing is proof. Is the infrastructure secure and compliant? Well, there are many ways to test this, and in most enterprises, several places where this kind of testing gets done. But we can add tests to our code as well to help ensure that it is secure and compliant with our organization policies. Testing also helps us make quicker and safer changes. We can prevent breaking old code when we need to make changes. And also, if we have sufficient tests that cover our requirements, then those tests must, of course, pass. And finally, testing can only be avoided but not prevented. If you don't test it ahead of time, then it hopefully will eventually be tested in production when a user uses it. So wouldn't you rather test it beforehand? So why don't we test? We know of good reasons to test, but why don't we do it? Firstly, there seems to be a high barrier to entry. You perhaps have no idea how to get started testing. This talk should help with a starting point. Developing tests also does take time and effort. How do we know that the effort is worth it compared to working on something else? Testing can be a bit of a bottomless pit. It is almost impossible to test everything. If our tests help us find bugs before code gets to production, then the test is valuable. This is because if something breaks in production, it comes with significantly more effort to rectify the problem versus fixing it in a test environment. And there's a perception that we need to test everything for it to be worth it. Well, actually, we can decide in advance what is most important to test. Surely something is better than nothing. If we decide to set up a clear, repeatable approach or framework for tests, then the development effort is a lot lower each time we reuse our process. And for other developers that begin to adopt the approach, it's also easy for them as it's only one thing to learn. And finally, the code changes can be done more quickly in future because you have a set of tests that cover existing functionality, and adding a new test to the existing framework should be quick. So I think that gives us some food for thought on the value of testing. Let's continue. So in this talk, we'll be using an example use case. We've been asked to develop some Terraform modules, including 2 modules listed on this slide: Terraform AWS S3 bucket for creating an S3 bucket, and Terraform AWS S3 bucket replication for replicating data between 2 buckets. This sounds simple, and well, it intentionally is, but you can already imagine how customer expectations could make this a challenge. The modules need to be easy to use. The customer wants to be able to copy-paste code and have working deployments. The modules need to work, and work in the organization's unique environment. The infrastructure needs to be secure according to organization policy, least privileged access. The replication needs to work in the same account, same region, but also cross-region and cross-account with a single module. It needs to be easy to maintain the code and avoid new fixes or features from breaking customer functionality. So, bearing in mind our objectives, let's identify what tests are the most valuable. Here I started putting our tests into different categories: things that we won't test, things that we will test, and things we probably should test, but we're not going to. So the won't test is things that we can take for granted, where testing them would have a high cost and a low benefit. For example, things that either AWS or Terraform or the Terraform AWS provider should always provide for us. The things that we will test are things that have a high benefit to testing and a low cost to implement. For example, the core functionality that users would depend on in our module, the usability and the documentation side, or testing that security best practices are being followed. And we can also add some tests for standards so that we can easily reuse what we do. Then the category of things we should test are things that have a benefit to us but a high cost of testing. These are things that we won't test yet. Maybe we can get to them later. If we review the list of will test, then we realize we need 2 main components. The first would be working examples that we can deploy into an actual environment. We can test S3 replication in its various forms, and we want to test that our code will work with the Terraform versions that we have in our organization. And the second component is static code analysis. We can scan our code for problems and remedy them before anybody else even views our code. So this slide is just to summarize the weapons of choice we will be using for testing our Terraform modules. Soon we're going to dive into each tool in more detail. For the working examples part, we'll use Python and Terraform, along with the Python libraries PyTest and TFTest. For static code analysis, we'll talk a bit about using Precommit and Terraform, as well as TFLint, Terraform docs, Chekhov, and TFSec for static code analysis. And finally, we'll need a way to automate our tests and ensure that they run with each change. For this, we'll use GitHub Workflows. GitHub Workflows will execute the tests above and also run a Terraform min-max version check, so we don't have to do that elsewhere. Oops. There we go. So we're almost ready to look at some code. Let's briefly touch on why we chose to use Python to test our examples. So why Python? It's a commonplace industry tool. It's easy to pick up and learn. There is a large ecosystem of libraries to pull in and use for testing anything we want. The AWS Python client is mature and well documented, so it should be easy for us to get off the ground. Python is very flexible and not strict about types. We can write tests without worrying about being efficient, type strict, etc. Whatever is the easiest hack to get the test to work. Python is also available on most platforms. We will specifically make use of two Python testing libraries, PyTest and TFTest. PyTest, as you can see on the slide, is a full-featured Python testing framework to execute our tests. And TFTest is another Python library that can wrap the Terraform executable and expose convenience methods that we can actually use in our tests. Let's now walk through how the tests work by reviewing our Terraform AWS S3 bucket module. Our module has an examples folder, which contains all of our examples. Terraform module registries also look for this folder and provide a link to the examples in the UI if they are present. Each example will be in its own subfolder. For the S3 bucket module, we have just a single example, but for the S3 replication module, we will see several examples. So let's open our basic example. The example itself is actually self-documenting. You can see we've generated a README file, and we use Terraform docs to do this. The README file contains some of the source code. This draws attention to important code without requiring the user to sift through various Terraform files and without requiring us as the engineers to maintain this. You'll see at the top of the example is a bit of boilerplate code for generating the resource names and any other supporting resources that might be required for the module to work. And then there is a section for the actual example of the module showing an implementation of it. The idea is the user can easily understand this code, copy-paste it, and make minimal changes, and it should work in their environment. But it also helps us for testing. Notice that in the example module, the source parameter is set to point to the actual source code rather than to a fixed version. So this is for two reasons. Firstly, the user must explicitly provide a version rather than us having to maintain a version number here as we release new versions of our module. And secondly, we can test this example actually works with the source code we have by running Terraform in this directory as the working directory. If we do make any changes to the module source code, then we could come here, do Terraform apply, and test the infrastructure manually if we wanted to. This testable examples is a very powerful approach. We use an example both as the interface to our user and as something that is tested to ensure it actually works. A user can therefore trust that using the example will provide an expected result, and we can deploy and eventually test the examples, which ensures they are up to date and there is no regression in functionality. Now let's get to the exciting part. How will we actually test this code using Python rather than just running Terraform commands against this working directory? So in our module, you'll notice we also have a test subdirectory, and all of our Python tests will sit in here. So let's open our only unit test file. They all start with test underscore, and in this case, there's only one. This will be for testing our basic example. This code has two parts. There are test fixtures and the actual tests themselves. Test fixtures are useful for preparing for tests. They provide a fixed baseline so that test functions can execute reliably and produce consistent, repeatable results. The test functions are the individual unit tests that we want to run. Test functions can also use other functions, and they can use test fixtures. Now, ideally, when we write a test function, it should test a specific small part of our code so that if a test fails, we can easily tell what went wrong. However, we know that doing a Terraform apply and destroy for each individual test would be inefficient. We need an ability to do an apply and destroy before and after a set of tests, sort of like a wrapper around a group of tests. This is where test fixtures and fixture scopes are extremely useful. We can define a fixture so that we create infrastructure once for all our tests, or once per Python file in this case, or once per test function if we really want to. So here we define a fixture that instructs Python to use the Terraform code in the examples/basic directory and reuse that configuration for all subsequent tests. The fixture is defined with a module scope, which in Python's language means just for this file. So the infrastructure will be created once and destroyed once, regardless of how many unit tests we have in the file. Now let's review the individual test functions to see what is being tested. Firstly, there is a basic test that Terraform can actually create and destroy a module. It tests that Terraform apply must have run successfully. This test is probably not compulsory, as the other tests imply that this one will also pass. Secondly, there is a basic test that we did indeed create an S3 bucket. Third, there is a more detailed test that the S3 bucket encryption is configured correctly using a KMS key, and that bucket key is enabled on the bucket. This reduces cost per our organization requirements. And the fourth test is a test that the bucket policy is correct per our organization requirements. Let's now do a small deep dive into the test for the bucket policy. You'll notice that this test function accepts an argument called output. This is actually automatically provided to the function when the tests are run, because the name of the parameter matches the name of our fixture above. Okay, just scrolling down, there we go. So our fixture runs. It creates Terraform infrastructure via Terraform apply, and then it runs Terraform output and imports that data into Python and places that set of Terraform outputs into the output variable when calling our function. Remember, the fixture will only run once as sort of a wrapper over all the tests in this file. So only once all the tests are done, whether successful or failed, will the Terraform destroy be executed. Inside the test function, you'll see that we can refer to the Terraform outputs and then use them for testing. For example, we can read the bucket name, and we can read the apparent bucket policy. The reason I called it apparent bucket policy is because the module is producing this output, but how do we know it is a bucket policy and not just some JSON document or some other artifact? How do we know that it was actually attached to the bucket? What if someone changes it in future and the new policy breaks our organization or compliance requirements? So this test verifies that our policy is indeed compliant. And towards the end, you will see over here that we do an API call to AWS to prove that indeed the policy is attached and correct. Now, this is still a very simple test, but let's briefly compare it to one of the tests in the S3 replication module. Here is our S3 replication module. You'll note that it has a very similar structure to our S3 bucket module. And indeed, we can reuse this structure and this approach on any number of modules we wish to create. Now, if you have ever had to set up S3 replication before, you would know that it is an error-prone task to find the least privilege policies needed, whilst also ensuring you can support cross-region or cross-account replication with buckets that may or may not be encrypted, for example. Now, imagine manually testing that you didn't break something when updating your module to cater for each of these requirements. So instead, you can write tests that check if you can add a file to a source bucket, wait for it to replicate, and verify that it arrived at the destination. So here are some of the example Terraform code that shows our user how to implement each scenario. They could simply go into the example, copy, paste, and configure the code, and it would behave as they expect. We also have, of course, tests that cover each of the modules, therefore running the Terraform apply and destroy on them, and allowing us to test functionality. For S3 bucket replication, if we look at the test file, we can see that it has some functionality for creating objects in a source bucket, waiting for them to appear on the destination side, and verifying that the replication completed successfully. So we can write Terraform examples that show our user how to deploy the module for each scenario, whether it's cross-region, cross-account, etc., We can cover it with tests, and now you and your user can trust that the code works, and any problems are possibly something in the customer environment and not a bug in the replication policies or in the infrastructure. So the user copy-pastes an example, and they can be sure that it works. In other words, it is tested to meet both their and their organization's wider requirements. Now I'd also like to show you conftest.py, which is a file that is also part of the testing puzzle. You'll see it in the tests subdirectory. So conftest.py can have several purposes. For example, importing external plugins, creating functions and fixtures that will be used by all tests, or automatically signaling to PyTest that there are actually tests in the directory where conftest resides. For example, here we use it to import the tftest Python library and also to create some functions that map our Terraform example directory to a Python test that we want to execute. That part is over here. You'll see that two search paths are being set up. One is for finding Terraform examples in our examples folder that we've seen. And another search path is where we can place additional Terraform test code that maybe we don't want the user to see, that it shouldn't be listed in our examples. The additional Terraform tests could be useful if we want to test submodules or specific edge cases, that if they were included as examples, they would clutter and detract from the working examples the user is actually interested in. In this file, I'll also highlight the getTF function over here, which sets up the tftest library to execute Terraform against the relevant code, such as configuring the working directory to be where the examples are. There's a lot of boilerplate code here that would clutter our unit tests. Putting the common functions here means that we can also copy-paste this conftest file to other modules and reuse our testing approach. Eventually, we could put this boilerplate code into our own Python library and just import it. Lastly, there are two helper functions which we reuse in our tests. The first is Terraform plan, which runs a Terraform plan and returns the plan output to be tested. This means we could test that a plan is valid without actually doing an apply and destroy. The second function, Terraform apply and output, runs Terraform apply and then runs Terraform output, which is a little bit different to a plan output. It then also makes sure that Terraform destroy is run once the tests are completed, and even if they fail. At this point, we can actually just run PyTest in our local development environment, and it will execute our tests, creating our infrastructure and running the tests against it, destroying it when it's done. So over here is our wonderful IDE, and we are going to do a live demo, and hopefully it will work. So in our Terraform AWS S3 bucket repository, we can simply run PyTest, and provided that we have authenticated with AWS and configured our environment correctly, PyTest will begin executing all of our tests. In this case, there's only one. The first thing it will do is do our Terraform apply, and then it will iterate across our 4 tests for this module, and finally it will do Terraform destroy. So that is what it is busy doing at the moment. While we wait for that to execute, we can move on and jump back to it, because it will take some time. But I can just point out it is actually doing something, because in our examples basic folder, we can see some Terraform files have popped up. Remember, this is the working directory when our test is actually running. On this slide, you can see how to set up your Python environment so that you can actually run these tests. I'm not going to go into too much detail here, but the steps are here if anyone would like to use them, or anyone is not familiar with how to set up a Python environment. Okay, let's now discuss remote automation with GitHub workflows. We know that we can run our tests locally using PyTest, but what if we forget to run the tests? Or what if another developer is contributing a change? How do we know that the tests have passed? Well, we can use GitHub workflows to execute our PyTest command, for example. Then whenever there is a new pull request, we can run the tests against it and see the test output in GitHub. Specifically, we use GitHub workflows to test the following things. Firstly, ensure that our pre-commit checks, which we'll get to in a moment, and our Python tests are executed. This is using our pre-commit and tests YAML file. Secondly, we can test that specified minimum and maximum Terraform versions work, and we have a workflow file for this. These YAML files are stored in our repository in the GitHub Workflows directory, and they'll be executed by GitHub on each pull request. Let's review a sample pull request now. If I can just find my browser, there we go. So here is a sample pull request that was closed some time ago. If we go to view details, we'll see all the different checks that have run against this pull request. And if we go to the checks tab, we also get a bit of a summary or overview of what has actually run. If we click on pre-commit and tests workflow, we'll see the specific steps or jobs that have executed. And unfortunately, because this pull request is a month old now, the logs have been deleted, as you'll see if I click on them. But luckily, I have a slide for that. So in the slide, you can see a screenshot of that the Python tests actually completed for this pull request in GitHub. And this pull request was for the S3 bucket replication module. So you'll notice in the slide that there are actually 3 tests that were run for this particular module: the examples basic, the cross-region example, and the multiple destinations example. So on GitHub, it's quite easy to see on the pull request that our Python tests and our Terraform code is actually working before we merge our code. Okay, we should have about 10 minutes left in our talk. Yes, we do. So for the remaining time, I'll talk about testing via static code analysis using pre-commit. So what is pre-commit? Pre-commit is a multi-language package manager for pre-commit hooks. You specify a list of hooks you want, and pre-commit will manage the installation and execution of any hook written in any language before each commit. So when you attempt to do a git commit, Git will execute your installed pre-commit hooks. The commit is only applied if all of the pre-commit hooks are successful. So why is this useful? Firstly, it is language agnostic. This is great because Terraform repos can contain a variety of code, some Terraform files, some YAML, some Python, some shell scripts, for example. Pre-commit gives you a single place to define the static checks for all the code in your repository. Secondly, there is a huge set of hooks created by the community, which allow you to get best practices in your repo by simply picking from and configuring the community hooks. Pre-commit is a package manager, and it can fetch and install the hooks automatically. You just need to specify the hooks you want. Generally, because pre-commit runs locally and before every commit, we can use it to do lightweight testing, where there is no dependencies on external environments. For example, I use it to format code for all the different scripts. It can fix up formatting for us. Pre-commit can ensure that our documentation is generated automatically and included with our code changes. Pre-commit can help us to check and prevent common mistakes, like large files being added to a repo, or worse, credentials, like passwords, tokens, private keys, from being added. And pre-commit can help us not commit to a protected branch, like a main branch or master, instead of committing to a feature branch. And of course, pre-commit can always be disabled or skipped entirely if required. Now, we can't guarantee that every developer will install and use pre-commit when making changes. So we need to run it remotely as part of our GitHub workflow to make sure that the checks indeed do pass. It can especially become a challenge if developers work on many different repositories that use different versions of the binaries, or if the developers use different operating systems. Fortunately, you can always skip the pre-commit checks locally and then require them to run in your GitHub workflow, where your environment can be created consistently. Let's briefly look at the pre-commit file in our repo. And remember that this file can be reused on all your different modules just with minor changes in configuration to suit the particular module that you're working on. So here is our pre-commit YAML file. If we wish to run the checks manually, we can by simply typing pre-commit. Let me just move our window so that I can see our command line here. One moment. There we go. Now we can see over here. Pre-commit run-a, which will run all of our pre-commit hooks on demand. However, we can also do pre-commit install to make sure that the checks run on every commit. As you can see from reviewing this file, we have various static checks that pre-commit does, and it does a bit more than that as well. We use it for generating our Terraform documentation. So here is what we use for generating the READMEs for the example files. We also have Terraform format, Terraform validate that we run, Terraform lint, and then tfsec and checkov, which we'll talk about just now. We also have various hooks covering Python formatting, because we know we have Python tests, so we should format them nicely and validate them. And any shell scripts that we might have in our repo can also be tested and checked. And finally, some general hooks that check for silly mistakes, large files, credentials, and so on. You can go through the list of hooks yourself and pick and choose which ones you like, as I mentioned. You can see that our pre-commit actually failed in this case. Most of the checks passed. The one that failed is the do not commit to branch check, because I'm currently on our develop branch, which is a protected branch. So pre-commit is doing its job. Okay, let's talk a little bit about static code analysis with Checkov. So Checkov scans cloud infrastructure configurations to find misconfigurations before they're deployed. Here is a brief example of Checkov running against our S3 bucket module. And in this case, Checkov helped us to consider S3 bucket logging, as well as replication and other checks that we might not even have considered when developing our S3 bucket module. So tools like these are super helpful for sort of identifying other configuration and security issues and other potential misconfigurations that might not be apparent when you're developing your module. Another benefit of Checkov is that it actually covers more than just Terraform code. So the other scripts in your libraries the other scripts in your repo can also potentially be checked. Here is an example of how we might rectify a finding from Checkov. So in this case, we enabled bucket logging by creating a resource, because that's important for our organization. And in other cases, maybe we choose to skip specific checks because it's actually irrelevant for what we're trying to do. So all of these things can be configured in code, and it's relatively easy to see what's going on. We also make use of tfsec. So tfsec is a static analysis security scanner for your Terraform code. Why do we also use tfsec as well as Checkov? Well, why not, right? More checks are always good. And tfsec tends to do a bit more in-depth security scanning of our code, whereas Checkov has a bunch of different checks that it can run. So here's an example of using tfsec, and it picked up a finding on our code. And in this case, there was an issue that our KMS key does not have rotation enabled. There's a nice description of what's the impact, as well as some links to information and how to rectify this. In this case, we opt to skip this check because the place where we create our KMS key is actually in our example, and we don't really mind that it's not going to be rotated because we're going to use it just for testing. We spin it up and spin it down, and it's not really used for anything, but maybe it's important to you. So here's perhaps some examples of where you can configure tfsec. There's a configuration file to add exclusions, as well as you can add comments in the code for certain checks to be skipped. And that's it from me today. So thank you very much for attending this talk. This is a brief summary of what we discussed and links to the source code if you wish to review it. There's obviously a lot more to testing in general, but I hope this talk has shown you how to implement most of what you might practically need. If there are any questions, I'll be available in the chat for a little while afterwards. Thank you.
Thank you very, very much, Bjorn. That was an awesome talk there. I particularly enjoyed testing. I know that testing is not just to find bugs, it's to build quality systems. So thank you for that one. Sacha on YouTube says pre-commit is awesome. She agrees with you. And just a quick note, if there is anyone joining, this is HashiTalks Africa. You can follow us on YouTube and on LinkedIn. It's streamed live. And somebody asked a question as well concerning if this is being recorded. You can find all of the talks on HashiTalks Africa playlist on YouTube. Thank you very much. So, Rob.
Thank you. I'm a bit different to you. I hate testing. I really do hate testing. Writing tests is the easy part. Knowing what to test, yeah, that's the difficult thing. And yeah, I have really struggled with that throughout my career. So yeah, it's always good to hear talks around these types of topics, because I believe it will expand our knowledge, and people like myself will eventually get better at testing and maybe even like it one day. But yeah, thank you so much, Bjorn. So introducing our next speaker, also from sunny yet cold Cape Town, is Sven. Now, Sven, in his own words, he fiddles with stuff in a DevOpsy way, which I love. So Finn is going to be talking about embracing technical debt, which I'm really intrigued about, because I run 100 miles in the opposite direction of technical debt, but you can't avoid it all the time. So I'm curious to hear this talk and what kind of take he's going to have on this. So Sven, over to you.
Right. Technical debt is usually kind of a bad word, or a bad pair of words in our industry. So today I'm going to be talking about how Peach Payments Engineering tackles technical debt, whilst still trying to deliver strategic features and business growth. I'll go through an agenda briefly and talk a little bit about who Peach Payments is, my current employer, and what it is we're trying to do. And then I'll show some examples of what's going on. So my name's Sven. I'm currently a senior DevOps engineer at Peach Payments. I've been fiddling with stuff in a DevOpsy way for about 20 years, and about 10 of those I've spent in fintech. I'm also a husband and a father of 2 young daughters. And as Rob mentioned, I'm currently living in Cape Town in South Africa, which is where Peach Payments has its head offices. The agenda for today's conversation is going to be fairly straightforward. I'm going to go through a little brief history lesson, talking a little bit about Peach Payments, where it came from, and the sort of how we got to technical debt, or what technical debt exists for us. Then I'm going to talk about what I think technical debt actually is, and generally how it's presented in the industry. And then from there, I'll go through some examples of what we're doing to work with that, and then wrap up with some final thoughts and some kind of takeaway key points from the conversation. There's a fair amount to get through, so I'm going to go through this quite quickly. But yeah, hopefully it'll all be fairly straightforward. So, brief history lesson. Peach Payments is a leading payment gateway in Africa. We aim to provide a complete toolkit to help businesses accept, manage, and disperse payments through web and mobile platforms. And our mission really is to be the infrastructure layer upon which African businesses and entrepreneurs build and thrive. It's a pretty ambitious goal. And it's also a very, very highly contested space at the moment. I think if anyone's been paying attention to the fintech industry in general, you'll know that things in Africa overall are heating up very much at the moment, and there's a lot of interest in African fintech. And so we're in a fairly competitive space. Just as an example of how competitive that space is, we've seen revenue growth of over 650% just since 2020. Now, obviously, the impact of COVID-19 with a lot of businesses going online had a significant amount to do with that revenue growth. But our revenue growth numbers have been consistently very, very high. And so we've seen rapid growth, not just from a revenue perspective, but also from an organizational perspective in the last few years. And that's kind of where the wheels start to fall off a little bit. On the one hand, it's a good thing, but on the other hand, there are some challenges that come with that. So in the beginning, things were really simple. Peach was founded in 2012 and went through a brief incubation period at a Google incubator for about a year in 2013, 2014. And the initial product offering was a classic monolithic web app. The infrastructure was really simple. The code was relatively straightforward. There was a web front end on a server, and there was a database on a server, and that was kind of it. And one of the key things at that time was that all of the engineering was done by contractors. There were no staff engineers. There was no ownership of the software engineering at all at Peach at the time. But things grew. We got more customers, and we grew, and time went on, and we went from one contracting team to another contracting team, and contractors came and went. And a few years later, sort of around 2020, things were complicated, to say the least. We still had that initial monolithic web app, but there was also another web app or two, and there were about 500 Lambda functions, and there was a whole variety of database technologies. There was some NoSQL. There was some caching going on. There was some messaging happening. There was some queuing. We had various hooks and triggers and gateways and networks and blah, and blah, and blah, and blah, and blah. I mean, this is just like a fairly typical story, right? Things grow and things sprawl and things scale, and there's more and more and more. And we're not very good, I think, as engineers in general at taking away. We're pretty good at adding. It's what we're paid to do, right? And with this sprawl, all of this technology, came a bunch of other things like manual deployments, and there were no pipelines, and there was little to no automated testing, and there was little to no tracing, and there was little to no monitoring, and there was little to no alerting. There were pockets of these things, and depending on which contracting team had done which bit of work at which time, there were some things that were done really well and other bits that were left behind or not done at all. And these are kind of, you can start to see these are the beginnings and the sort of the birthing place of technical debt. It's like as you move quickly, and as there's pressure to get features out, and as growth is the sort of drum that everyone's beating, sometimes corners are cut, sometimes it's a lack of experience, sometimes it's just a lack of foresight. But for whatever reason, there's this growing amount of stuff that remains undone. And there are some key things that come out of this situation. And when you stop and look at it, if you look at Peach Payments right in the beginning, and then you look at Peach Payments circa 2020, you can see that there, if I took a snapshot of Peach Payments in 2020 and I looked at the whole code bases around about when I joined, there was a lack of standards. There were no real naming conventions. There were a whole variety of different languages being used, programming languages. There were also different versions of those languages being used. There was different styles of testing, different testing frameworks, varying degrees of automation, some of it non-existent, some of it bash scripting. There were no real pipelines per se. And even down to like trivial little things like tagging. There wasn't a consistent way of tagging things, or there was just no tagging. So right from the really big things to all the small little details, there were huge gaps and inconsistencies. And there was also a lack of a paved road to production. concept of the paved road being like the right thing to do is the easy thing to do. And so engineering teams, and at this stage, we'd now started hiring the first staff engineers, and we were still working with contractors as we are today. But we'd started hiring our first engineers. And so as people were being onboarded, they weren't really sure what the right thing to do was, and they weren't sure what the kind of approved way of doing a thing was. And so there were people kind of reinventing the wheel as they went. Everyone sort of found their own way of doing a thing, or the most appropriate way of doing a thing at that point in time. So there was generally this lack of consistency, and there was also a lack of shared awareness. So if you looked at components or even features or services as a whole, as individual things, there might be a good understanding or a deep understanding of a particular component or a feature or service, but there was no sort of global awareness of what was going on. There was no shared awareness of the entire platform, the entire system, or everything that went into it. And this led to a bunch of confusion and fear and uncertainty and hesitation. And generally speaking, there was a large cognitive overhead, a lot of thinking to be done about something that we felt should be easy. Things that we felt should be straightforward were becoming more and more complex to talk about and to think about and to plan for and to account for. And it was generally a relatively unpleasant space to be in, and not really from an organizational perspective, but from a technical perspective. It's not nice to be in a situation where you're not quite sure of what the right thing to do is, or you're not quite sure if something is going to work or not. And we know that this is a solved problem, right? There are good techniques for handling this sort of thing. But it's the implementation of those techniques and the actual execution of all of those right things to do that are really at question. And this is essentially what we consider to be technical debt. And so as a result of that inconsistency, there was a bunch of crisis management going on. We had system outages and service outages. There were a bunch of security risks that we were aware of, or that we became aware of over time. And it was, like that classic meme, this is fine. But actually it wasn't. And so when I joined at a very interesting time for Peach Payments. I joined when they were starting to onboard their engineering effort, to own their engineering effort. And I joined sort of right at the beginning of the bootstrapping of a DevOps sort of culture and movement within the organization. So I want to take a step back just for a second and talk briefly about what technical debt is. Technical debt is a concept. It's a metaphor for describing something. It's not really the thing itself. There isn't really a debt that we owe from a technology perspective, but it is a useful concept. And it's evolved from within the software engineering domain as a means to describe certain characteristics of software development in general. It was originally, the sort of idea of technical debt was originally attributed to Ward Cunningham, who was working for a financial institution at the time, which is why there's this link to the notion of debt and money and currency. And he's quoted as originally saying, if we fail to make our program align with what we then understood to be the proper way to think about our financial objects, then we were going to continually stumble over that disagreement, and that would slow us down, which is like paying interest on a loan. And so he was using the notion of paying interest on a loan as a way to describe the pain of constantly having to rethink about something that didn't map cleanly. And it's this cognitive load that is really key to the notion of technical debt. So the way I like to think of technical debt is that it encompasses everything which is not the way it ought to be, which is a pretty broad definition, but I'll explain a bit more in detail what I mean. So anything which isn't the way it ought to be and which causes cognitive overhead when thinking about or working with the system is what I consider to be technical debt. And the thing is, how things ought to be is part of a bigger conversation which has to be had beforehand, or at the very least has to be started at the beginning of dealing with technical debt. So when you're assessing or trying to overcome technical debt, you have to have this bigger conversation of how things ought to be. And a good example of this is if we agree internally as an engineering organization that manual deployments from an engineer's laptop is okay, then not having a pipeline is not technical debt. And I think that's important because it's very easy to get caught up in this notion that there's a perfect way to do things, or there's the way that everyone is doing things, and that's what we need to do because everyone's doing it. There might be good reasons for them doing it, and that's okay. But there also might be good reasons for you not to do it. And if you are constantly thinking that you should be doing something when in fact it's okay to not be doing that thing, then worrying about whether or not it's technical debt is actually the problem, not the technical debt itself. Perfect is the enemy of good. And so, like I said, this conversation, and it really is a conversation that you have to have with everyone, is so important. Before you get to like dealing with technical debt, you've got to define what it is for you, and you've got to define what the parameters and boundaries of it are, and then you can really approach ways to deal with it more effectively. So I want to talk a little bit about some examples, and this is, specifically I'm going to be talking about Packer and Terraform as just a couple of the tools that we've used internally to deal with and kind of overcome the technical debt that we have incurred over the last decade or so. These are mostly going to be from a DevOps or infrastructure perspective, just because that's where I work mostly. But this is by no means limited to just the infrastructure component or domain of the organization. This is a conversation that's happening across the engineering division. So let me just jump straight into it. So I'm going to talk first about Packer. We use it really for very straightforward things. It's not complicated. I'm not going to be doing any technical demo. We're using Packer to generate a standard AMI in AWS, essentially. There are one or two other things that we could use it for and do occasionally use it for, but generally speaking, we're using it to produce a baseline, a single location to update operating system choice, baseline of packages and utilities that are installed into the operating system. And this baseline includes regulatory and compliance components as well. So this is just a code sample. You can see we have a bunch of variables defined. This makes it relatively easy to pass in these attributes from a pipeline or from a shell environment, a command line, if that's how it needs to be invoked. But setting up a bunch of variables means that we can, in order to set up a bunch of variables, you have to talk about what something is called, and you have to talk about what thing is required. And so you can start to see there's already some of these conversational pieces being documented here in the code. You'll also notice there's a DD API key environment variable. So even things like our choice of monitoring platform, these are things that we talk about, and then we can bake in and embed into the very baseline. So, when someone fires up an EC2 instance, for example, they've got there's a bunch of decisions that have been made beforehand that come pre-baked for them. And this is the beginnings of that paved road that I mentioned earlier. And this is also a way to preempt the introduction of technical debt by front-loading a certain amount of effort. You can ensure that when someone goes to make an EC2 instance, they're not randomly selecting from a bunch of different operating systems. They're not randomly selecting an instance size. And so we can start adhering up front to building things the way they ought to be built based on the agreements that we've already made. And I mentioned briefly compliance and regulatory stuff. So we actually use Ansible for that. Packer's ability to reach out to other utilities as a provisioning mechanism is really, really useful in this case. And so we have a bunch of operating system hardening that we do, and that includes components for our compliance and regulation frameworks that we have to adhere to for our industry. And so again, these things become baked into the utility from into the resource from the beginning. And it also means that they are located in a single place where we can go and make changes as those compliance frameworks get updated, or as the regulatory requirements get updated. We can go to a single place and update them, as opposed to having to do it all over the place. I mentioned that we also use Terraform. We use Terraform in preference to CloudFormation, simply because we are in fact multi-cloud. We run some workloads in GCP and we run some workloads in AWS. Terraform is great for a bunch of reasons. Composability is one of them. Composability and reusability. I think in previous talks we've had today, there's been mention of the fact that modules are a very, very powerful feature in Terraform, and they allow us to make infrastructure from pre-baked pieces very, very easily. It also provides a standard deployable unit of infrastructure. And by that, I mean something that all engineers can accept and be comfortable with and be aware of. And with that comes a standard interface. So there's, if you design your modules correctly, you can essentially produce an interface for customization. So you can compose different modules to create a thing, and then that thing can be customizable for a specific use case through the use of variables. And this is a very, very powerful way of building up infrastructure and allowing people to access those kind of decisions that you've already made, and so use the right things at the right time when building components for their needs. So yeah, just continuing on, this is again a simple sample of Terraform code. We have a source file here, which is actually the definition of a module. You can see that this module inherits from an existing module. So someone has gone through the effort of making an EC2 module, and then this workload runner module inherits from that. So a bunch of decisions have been made. We're inheriting from those decisions. You can see that this also inherits from the standard AMI that we produce in Packer. So we know that when this runner instance gets created, there's a whole bunch of thinking that's gone into it already. And so any engineer can come along and use this and be certain that they're getting a baseline standard of quality and a certain expected amount of behavior and everything else kind of baked into the product. And that's really, really useful from a technical debt perspective, because it means they don't have to remember to do that stuff, and they don't have to think about or worry about whether that is the right stuff. This module here is an instance of a runner workload. You can see here that we've got some things that are kind of configured, and there are a couple of variables that are available in this sample of the code. This then becomes the customizability interface. So this presents a really straightforward number of choices for someone to make, and they don't have to think about, oh, well, what does it mean to like include a VPC or a subnet, or what does it mean to worry about ingress, or like what instance type can I pick or can't I pick, etc., etc. What monitoring should I have? Like, we've baked all of that stuff in. And I know I'm repeating myself, and I feel like I'm flogging a dead horse a little bit, but this really is very, very important. So if you're going to be thinking about technical debt, you've got to start looking at ways of eradicating it upfront by front-loading good behaviors and good decisions. And tools like Packer and Terraform, as people have mentioned before in talks earlier today, are really useful and powerful for this kind of thing. So I want to wrap up quickly. I'm cognizant of time, and I want to just talk about some final thoughts. What does this all mean? To give you an example, we've gone from 0 to 20 modules just in the last 2 years alone. Now, the number 20 doesn't sound like a lot, but to come from 0 kind of Terraform implementation to 20 modules that can be reused and composed with other modules to create infrastructure is a significant amount of leverage that we can apply to eradicating the technical debt and preventing technical debt in the future across our infrastructure. We've also got we've gone from 0 to like over 40 projects that use Terraform in particular for the creation of infrastructure. And this is significant as well, because it means we went from having no automation of our infrastructure to having a significant number of our projects that rely on that infrastructure automation very heavily. And it's baked in from the beginning. So now we have 40 projects that from a technical debt perspective, we can say have little or no technical debt. And it's not just because they use Terraform that they have no technical debt, but it's because they use Terraform in the way we say is the right way to do things. And that, again, is an internal conversation, and you need to have it with your engineering folks, and you need to talk about what the right thing for you to do is. But it means that we have 40 projects that we don't need to really stress too much about, where there's a consistent way of conversing about them. There's a consistent thinking that goes into them. There's a lack of that cognitive overhead that comes when dealing with that project, because you just know that things are a certain way, and that's the way they're going to be. And what this has meant for our team and for our business is that certain tasks have gone from taking a day to complete to taking an hour to complete, because we don't have to have those conversations every single time we implement something. We don't have to argue about it. We don't have to talk about it. We don't have to consider the options every single time. And a bunch of stuff is pre-baked in for us, so we don't have to repeat those tasks. Repetitive, commonly performed tasks, things like adding users to systems or standing up infrastructure in a development environment or a test environment, or handling security concerns like security groups, or things like that. These things, it's like death by 1,000 cuts. If you don't have this stuff defined up front, or if there's a different way of doing things, or if there's a significant amount of technical debt involved in doing something, then you're going to feel that pain on a daily basis. And again, coming back to Ward Cunningham's example, that's like paying debt on a loan. We also have better security as a result, because we can preload a bunch of these things and predefine a bunch of security guidelines and controls. We have better visibility. We have greater certainty that we're doing the right thing from the get-go. And as you saw, we can bake in our compliance and regulatory frameworks from the start. And this results in a faster path to production. We get to production faster because there's a smoother ride and there's less talking and concern and wondering about things as we go. And then maintaining things in production is a bit more straightforward as well, because there's a consistent way of dealing with these things. There's a consistent interface to everything, and there's consistency in the thinking and in the decision-making that goes into all of these components. So, like I said, I'm aware of time. I'm a little bit over. I want to thank you very much for your time and attention. I hope you got something out of this presentation. If nothing else, I hope you were provoked into thinking a little bit about technical debt in a slightly different way. And if there are any questions, feel free to drop them into the chat or reach out to me if you want to discuss these ideas further. Thank you very much for your time and attention.
Indeed. Thank you very much, Sven, for showing us a different perspective to technical debt. I learned something from that one. Thank you so much. Okay, so right about now, I'll hand over to Rob to see what we have next.
Fantastic. Thank you so much. And Sven, I totally agree with something you said in that talk. Perfection is the enemy of progress. And that's something I always have to tell myself, because we're always striving for perfection, but ultimately we just need to do something. We can always look to improve as we go along. But yeah, introducing our next speaker, we have Abdurrahim. Abdurrahim is a software engineer and cloud architect, and they're going to talk to us about Waypoint. So over to you.
Hello guys, thank you all for introducing me. Well, today we will talk about Waypoint. As you said, it's a new project for HashiCorp, and it's a very powerful tool for developers. Okay, let's start. And my name is Rahim Subaili. I'm from Morocco. I work as a software cloud guy in at Optimize. Work mainly in telecommunication and payment services, and I'm very interested in cloud and distributed system. And today talks is about your point to Waypoint. I'm not here actually to teach you something, but I'm very fascinated by how Waypoint is easy and powerful, and I'm trying to show you that. So let's begin. Every application has a lot of phases or life cycles, and it starts like a line of code in your favorite code editor or IDE. It's mainly now we know that Visual Studio Code is the de facto standard of this, and everyone is using it. After that, you should write some tests using your favorite frameworks or tool. We are using Selenium as a de facto standard too for this one. After that, we should build our application to generate some artifacts. Those artifacts will be deployed and released somewhere, and will be operated by Nomad or Kubernetes or something like this. As you can see, we have 3 green circles. I mean here by green, like we are mastering this phases, and there is tools that there are standards for this, but for build, deploy, and release, we are hacking around to make those phases automatic and reliable if it's true. So our bottleneck is these 3 phases: build, deploy, and release. Why? Because there's a lack of standards. Everyone is doing his stuff by his own. We have a lot of, for example, we have a lot of artifacts to generate depending on the platform that we want to deploy to. For example, if you want to deploy to a Kubernetes, you need something like container to do that. If you want to deploy to some serverless platform like AWS Lambda or something like this, you need to write code in certain format and build for some specific target to do that and do those. So there is a lot of platform that make it hard for the developer to easily choose one tool to do all the stuff. And we generally create our bash scripting for that. Generally we use hacking around, like putting our scripts in some pipelines in CI/CD or something like this. So and for release, it's the same. For releasing here is like more traffic management. For example, if you want to do something like canary deployment or blue green or stuff like this, it's hard to do it like with tool that we have now. So here it's come a bunch. It's give us a very easy to use and consistent workflow. So we will mainly create one single file, one repo for our project that will englobe these three phases: build, deploy, and release. And of course, we can deploy and release to multiple platforms with single file. It's give us the confidence. Every developer that's deployed to some platform, it needs some visuals, logs, an URL for testing his release or his deployment version or something like this. So Waypoint give us this visual very easy, and is give us tools to check logs and go check our deployment in real time. The other stuff, it's very extensible, so everything in Waypoint is extensible. Platforms, builds, deploys, you just use built-in plugin by the team, or you create your own plugins and you deploy to your favorite platform or build with your favorite artifacts tool. Okay, the global architecture for Waypoint is something like this. We have CLI and the UI platform. It's like a PaaS experience. PaaS is stands for platform as a service, and this PaaS or this platform is give us all stuff that CLI give us too. So you have the choice to use the CLI, the command line interface, or you use the platform. So this is the client of our architecture, and we need a server somewhere to serve the Waypoint APIs. So think about it like a control plan for a server mesh and data plan. The control plan is the mind of our system, or the brain of our system, and it's communicate with the data plan. The data plan is the deployment or the VMs or the stuff that we are deployed on our own. And as you see here, we have something like entry point. Think about it like a sidecar injection here for like a service mesh. For example, if you are familiar with Linkerd or ASTO, it's the same thing. And this entry point is injected directly by the build phase, and it's built in by the Waypoint team, and use us and helps us to provide logs, to provide an URL, and to communicate between the server and our deployment on our favorite platform. There is a missing point here. It's not missing, but it's like a hidden part here is a runner. The CLI is scheduling a build, for example, or deployment, and the runner is doing the job. The runner mainly is, you can think about it like runner in CI/CD platform, for example. It does all the job. It can be a local runner, so in your local machine or something like this, or it can be a remote one. Same thing for the server. It can be for in your local machine or remotely. And of course, a single server can or a single CLI can talk to multiple servers. For example, if you have a server for production, server for the staging, something like this, same CLI can talk to all these servers. Okay. Okay, let's move to configuration. The configuration is pretty easy and pretty standard. Like we used to have the HashiCorp language. It's like an easy file with 3 phases here, or 3 block of codes. Every block of code is represent a phase of our application lifecycle. For example, here we have built. We are just using built-in plugins called pack to build the application, and it will generate an image. This image, it will be pushed to a registry, a public registry here in Docker Hub, and after that I will deploy this image in Kubernetes. So I will just use again plugin and with some parameters, and I will release in Kubernetes. Of course, I can deploy and release in different platforms as I want. We'll see that. So the power of this file or the Waypoint is give us one single file that's englobe all this stuff, all our workflow. It will be a code, and we can manage it in our version code. For example, it's give us the end-to-end experience from the build to the release. Okay. The build and deploy, it's pretty easy as we used to use our HashiCorp products. We just up stuff. So I Waypoint up my configuration file, and the magic is there, and I will just wait for 5 minutes or less, depending on your build and deployment tool, and you will get some visuals and URLs to check your code and logs and stuff like this. And of course, you can use the CLI or Waypoint app, or you can integrate Waypoint to your favorite Git operation. For example, you can integrate it to GitHub Actions or stuff like this. So it's easily integrable into a CI/CD pipeline. Okay, let's move now to the UI part. The UI part is like the client or our visual, and your team can go to one place to for example, check all the builds, check all the deployment that you did, the versions of the deployment too. We will see that in the example. And Waypoint give us a very, very cool stuff like real-time monitoring. For example, we can get status of the application in real time, and we can get the versions like you can see here, the version and the time that the version of deployment and the time of deployment and the status. Of course, the platform here is Docker, and we can see all the deployments and logs in one single place. Okay, I will show you a demo. You can find the slides in my GitHub, so you can just clone the projects and play with it. It's pretty easy. Okay, and here we go. I have two folders here at Docker and Kubernetes. Let's start with Docker 1. Let's have nothing special, just an HTML file here. Docker is running, and a Docker file. It's an Nginx-based image with some simple configuration in here. Like you can see, it's just like when you deploy your React application or something like this. And we have a Waypoint file. Waypoint configuration file here. It's have the project name, and it's have the application. The application here is named web. Hope you can see. I guess now it will be better. We have our application, and we have the first block. It represents the build phase, and second block it represents the deploy block. Both of them use Docker as a plugin. So I will just do something like you can let's take a look at CLI first. You can install it in your machine, and you will get something like this: a command line interface, login, build, stuff like this. Other commands, you can, for example, get context. Like, for example, if I context list, we get the context. Context is like the server that the CLI will talk to. For now, we just talk to my local server deployed on Docker. And to install a server, you can install it on Kubernetes, on Nomad, on Docker, on any platform you want, and the CLI will help you. You just need to do something like Waypoint install. You specify the platform and accept the tools, and everything will be deployed for you. And now let's, for example, go to the Docker project. First thing I need to do is to initiate the Waypoint. So I tell Waypoint to consider this as a project. So I just do something like init, and it will read the file and validate it. For example, if there is some issues in the file, it will pop it out in here and tell me there is something wrong. If not, it will just do something like this. And I will just need to do something like Waypoint up, and it will start the build phase. For example, here you can see logs of building an image here using Docker, and it will deploy it to a container, or in this phase it will deploy it to Docker. So as you can see here, it's give us the logs, and as we don't have a release, it will not give us a release phase for this, but we can specify it. For example, we just need to do something like and as we are waiting, I will just start a Kubernetes cluster using Minikube. Let's check if we have something here. Yes, we have something already there. Let's search for deployment. Okay, as you can see here, I can just do something like Docker PS, and I can see here my application up and running, and I can test it locally and stuff like this. We will do something like more exciting when we go to see the UI. The UI is something like this. The project is the same thing that I have in here. We okay, it's web. Okay, I guess I have some issue somewhere, but no worries. It just gives us a very beautiful visual, and I I think we can see this with all of project. So, and go to Kubernetes. Oh, sorry. Go to Kubernetes 1 and just init. Let's check in here. Yes, it's a little bit slow, but it's here. We can see all the deployment I did with the logs in here. Releases to the platform, and I guess there are some issues. Yeah, there is the logs in here, and we have the phases that we have in GitHub file, in the configuration file. And if I go there and I try to init the other projects, let's see the configuration file first. It's nothing, just some very simple Go application that will show us hello Waypoint, and the configuration file is pretty easy too. It's something like, I just need to remove this, and it's something like build using pack, so, and push to the hello Go image and use Kubernetes to save the application. I will just save it and Waypoint up for this. As you can see here, it's using pack to build the application, to build the Go application, and pack it as an image. And I guess I need to minikube tunnel. Okay, it's pushing now the image to a Docker Hub. After that, the deployment phase. It's automatically detect the ports in my application. Now it's creating the deployment on my Kubernetes. I guess I have something. Okay. I have some timed out stuff. But I guess if we just kubectl git deploy, we can see our application in here. Okay, I can just I guess there is some internet issues. That's why it's not deployed. But the essential is that we have one single file that's enveloped the 3 phases, and it's easy to switch from a phase to phase and to configure it every phase. For example, here for Kubernetes, we can configure how the number of replica, the probes of liveness and readiness, and we can specify the ports that we want to be deployed to, and everything else. And we can use the CLI or just go to the UI and see what's happening. It's a little bit slow, but the essential is Waypoint is very, very promising project. It's now in version, I guess, 0.8, and it's under a heavy development. Every week you will get some new version, some new stuff, some cool stuff. For example, we have in the version 0.7 the integration with GitHub. So we just introduce something like a GitOps. You just push to your GitHub and everything is running in Waypoint. And as you can see here, I have logs and stuff like this. Even if it's failed or stuff like this, I have logs and I can check my phases, see where is my errors and stuff that doesn't work, and I will fix them and redeploy using Waypoint app. And that's it for my talk. Hope it's pretty clear for you. You can see it's a very powerful tool and very easy to use. Just one configuration file and 2-3 command line stuff. That's it, and thank you for having me.
All right, that was another fantastic talk about a fantastic tool, Waypoint. It allows developers deploy, manage, and observe their applications through a consistent abstraction of underlying infrastructure. So thank you for that one, Abdurrahim. And I'll hand over to Rob now to see what we have next on the agenda.
Thank you. We have a returning speaker. I stand to be corrected here, but this could be the 3rd time she has spoken at a HashiTalks Africa. So it's my great honor and pleasure to introduce to you Anita Ihuman. She's given some fantastic talks in the past. I'm super excited for this. I've always gone back and rewatched her talks in the past. And I'm sure this is going to be no different. So over to you, Anita.
Once again, it's always amazing sharing my sessions on this program and conference. So my name is Anita, just like Rob said. Today I'll be speaking on the topic evaluating usability in technical documentation. Now we can all agree that no matter how elaborate our documentations are, our users always end up looking for alternative sources to better understand the product, like videos on YouTube, articles, and any other form of resource that does not actually rely on the documentation. Now you might be wondering why that is. Well, we're going to be discussing all of that during this section today. But before we do, a little bit about me. I am Anita Ihuman again, a developer advocate and a technical writer. I'm an open source advocate as well, contributing to prominent communities like the Chaos Community, Layer 5, and the Good Docs project, where I'm currently working on a landing page template. I'll also be sharing my experience on that during this section as well. So let's get into it. And then during this section, I'll try to talk about a few points like what exactly usability evaluation is, characteristics of a usable documentation, factors that influence documentation's usability, and a writer's role in usability evaluation. Then we're going to look at how to evaluate a technical documentation and why we should evaluate documentation's usability. And then our final note. So let's dig in. Okay, so a technical documentation basically can comprise of a handbook, manual guides, API documentation, whatever the case may be. But at the end of the day, the aim of this document is to help users to achieve a particular purpose, right? Either to fulfill what they're looking for, answer a question, answer a query they're looking out for, or whatever the reason this documentation exists for. But at the end of the day, we want that user to be able to fulfill that particular reason they're coming in there, and like the questions they're asking or they had in mind before coming across that documentation should be answered completely. And that's what we mean when we're talking about creating usable documentation. This is simply ensuring that the various users can learn, understand, and use the product's documentation however it is executed, or however it exists. Once a user comes across that documentation, they can like explicitly use that documentation and have a great experience while doing that. But the thing is, not every single documentation that we have today can be classified as usable, and that is why we're trying to understand why we should consider usability evaluation. So, what exactly is usability evaluation? This is simply a straightforward way to measure the efficiency of the resources that we have, or the resources that we have in our documentation, while ensuring user satisfaction. We want to be sure that whatever it is that our users are looking out for in the technical documentation, they can completely have 100% experience, if not 199% experience, that they can also come back next time whenever they have this similar challenge, without having to look for like alternative sources of um resource that can actually answer this question. So but we know that this is actually hard to achieve, because of course users will always be users, where we have people looking out for alternative links, and looking for ways that answer their questions of why exactly does this product help me, and how do I get involved, or why exactly does this product exist, and why do I need it, and how does it benefit me as a user. So these are all of the questions that your user would have while coming into your documentation. And the reason why we should actually consider usability evaluation is to make sure that these questions that these users have are completely answered, or even answered to some extent, so that they don't have to go over alternative resources, right? And in terms of usability evaluation, a documentation can be classified as usable based on several characteristics. First and foremost, a documentation is classified as usable based on its ability to be easy to learn. So users should be able to, successfully complete the tasks that they came to that particular document for at the end of the day, and without needing any external instructions or help with other forms of resources. Another thing that the characteristics that determines if your documentation is usable to your users is how efficient it is at the end of the day, because users should be able to accomplish the basic tasks that they're coming to, and the time within a short period of time that they're actually going through that particular documentation. Another thing is it should be effective, in the sense that how fast do users actually execute their tasks while going through this documentation. Now I got to realize that as a user, I spend less than 5 minutes on most documentations that I come across, and that only says that not only me, but so many other persons that are coming across documentation spend that equal or equivalent time. And so you want to make sure that your documentation is as effective as possible. So I can skim through in a space of under 5 minutes to 10 minutes. I get answers to what I am looking for. And I'm really happy with the experience at the end of the day. And then your another characteristics you should look out for in usable documentation is it should be error tolerant, in the sense that your product documentation, let's say you're putting together an API documentation, definitely at some point users are going to encounter one form of error or the other. Does your documentation actually track these errors and how to tackle them? Or let's say there's a strange error that a user does not know any part of documentation that tracks that. Does it frequently ask question also like tackle that, or is there provision to reach out to the team regards that particular error? That is what we mean by your documentation being error tolerant. So how many errors can users make, and how can they actually tackle that error using the same documentation that they are on. And then it should also be satisfactory, because at the end of the day, you want to make sure that the user is pleased with their experience going through this particular document or resource that you have provided for them. And all of this come together and makes your documentation to a user usable at the end of the day. But there are several factors that influence your documents usability. And we all know that evaluating the usability of a technical documentation is a vital part of document creation process. And the quality of a documentation actually depends on two fundamental groups or categories. First, the functional qualities. Under functional qualities, we're talking about the necessities that a document needs to, accomplish a goal. These factors range from the readability to the accessibility, the content quality, the intuitive design, the language diversity and inclusion, the visual and graphics. Now let's get into each of these qualities. Now, under readability, we're talking about how your document is placed in such a way that users can easily understand, read through the documents quite all right, and then understand the content that they are reading, both visually and cognitively. And then under accessibility, we're talking about how I'm able to like reach each and every nooks and cranny of a documentation in a very short time without struggling. And this also means that even people with disability challenges can also utilize your documentation without having any troubles. Let's say, for instance, I have a form of visual impairment. The documentation should have at least provision to toggle between dark mode and light mode, so that at any interval I can easily just go through that and be able to still use the documentation, right? Or let's say the text on your documentation are too small, I should be able to like zoom in or zoom out of the text so that I can better understand, or the heading should be so prominent that I can easily just take note of these particular pointers that I'm looking out for in your documentation. And then another thing to look out for is the content quality. The documentation's quality should be comprised of the necessary information that are actually key to the product. You don't want to put so much content that at the end of the day, I'm beating about the bush and I'm still not hitting the nail on the head. Now, I'm going to give a simple example of this based on the landing page template I'm working on in the Good Docs project. So I was assigned this task to take on the landing page template. And basically what we do is create templates for your technical documentation. So it makes your work easy for you to, just use the template and then use it as a guide to go ahead and create this document. Now, for a landing page template, however, I had so much difficulty trying to put this together. And at the end of the day, I created a guide of over 21 pages. I don't think anyone would actually read a guide of 21 pages, but for me, I thought it was really, really informative. It had everything that a reader would need or a user would need to successfully create a landing page. But at the end of the day, it was too informative, and there's so much content that I thought were necessary, but were not actually necessary to the user's journey or to whoever wants to create a landing page. And at the end of the day, there was just so much context that was not actually meant to be in the documentation, the landing page template, for instance. And so when creating your document, you want to make sure that you only highlight the necessary information that can captivate your audience attention in such a very short notice. And another thing to look out for is the intuitive design. The content and structure should assist the users in finding information easily. We're talking about having your navigations, having your search buttons where you can easily just search keywords and go straight up to the particular place where it is located. So many documents already have this, but there's some documents that still have not implemented features like the navigation bar for easy finding, or the side navigation that makes it easy for you to look at the key headings within a particular document. These are some of the intuitive designs that you could also consider in your technical documentation to make it a lot more usable to your users. And then another thing to take into consideration will be the language diversity and inclusion. Oh yes, we have so many persons coming across documentation that are not always English speaking individuals. and we want to make sure that your documentation is usable to every person, even those that are familiar with the our common language, which is English, and those that are not. And so it's good to consider this by putting, translation and ability to like toggle between different languages or different audiences based on the language differences. So you want to have that language diversity and inclusion for every audience that's coming across your documentation. Then the visual and graphic content. So many persons that come across the documentation enjoy interacting with a document by having that has graphic content, pictographs, videos, pictures, any form of imagery at all that makes the content a lot more elaborate for people to skim through. And this makes the experience a lot better. And for you as a writer, you might not see the reasons why, but on the user's point of view, whenever I read through context and I find it difficult to understand, I basically just go straight to the picture that is immediately underneath it to see if it better explains the context above or the context beneath. And that is how I actually better understand documents. And I feel like this is the same experience for so many other persons or so many other users that come across our technical documentations. And then on the structural end, this we're talking about the things that come together to make your document, the very little things that you should consider in terms of the sentences, the paragraphs, the headers, the structures, and all of this. We're talking about how clear your documentation is. Is it easy for people to just read through without having any need to go and read the dictionary? Is there like so much technical jargon that hinder the user's ability to just digest things immediately? You'd want to put that into consideration as well. And then how concise is your document? Now, I gave an instance of the landing page template I'm working on. Now, this template was very informative. Having 21 pages is a lot to put in a documentation. But at the end of the day, after scrutinizing the entire document, I found out that just 9 pages of everything that I have put together were relevant to the user, because most of it was just me explaining why certain things existed or why certain things should be done the way they should be. And I found a way to make it a lot more easier by using charts, by using tables, by just using pointers, easily just navigate to things. And at the end of the day, I moved from 21 pages to 9 pages in my landing page template. And that is what we're trying to achieve with how having a concise documentation. And then it should be consistent. While using a particular language, you want to either stick to one particular tone to make sure that the writer does not mistake whether you're referring to a particular product or a particular group of products, whatever it is. But just stay consistent with the tone that you're using, and also the tenses or the sentences that you're using in phrasing everything that you're writing on your documentation. Then you'd also want to consider the quality of the content, and then make sure that it is up to date at the end of the day. Now, a bit to explain on this up to date, you want to know that in an API documentation, for instance, having a simple or adding something as simple as a new command could actually alter the user's experience at the end of the day. And if that is not captured in your documentation, definitely that is going to give like a bad experience for your user at the end of the day, because they're going to be wondering where this new command came in and why the documentation does not capture it. How come I'm having this and the documentation does not track this particular form of information? These are all of the things that you want to put to place in terms of the structural view of your technical documentation. And then moving forward, what is the writer's role in a usability evaluation? Well, as technical writers, we play a very vital role in making sure that the document itself is usable to our users and the audience that we're trying to reach out to. But as a technical writer, the first thing you should always try to do is be the primary user of the product. So you want to have the first-hand experience of how a product works in order to put everything into writing the way it should be from the user's perspective. So if it means trying to practicalize the entire steps of how to use a particular product, then you should go through that to have the better understanding, and then understand the target audience that you're trying to reach out to. Then create a document according to how those audience might perceive the product. So let's say you're writing for beginners, your content should also like make it more explainable for beginners to understand. Let's say you're writing for experts or like more advanced folks, then you should also try to capture that in your technical documentation so people don't get confused while reading through the documentation. Now, as a technical writer, you should also try to consider minimalist writing. Now, by minimalist writing, I'm saying you should do less of putting together text and lots of writing, and try to adapt other ways in which you can convey information. We're talking about the graphical, we're talking about using videos, we're talking about using pointers and listing or tables or any form of writing that actually explains things in a more in a less congested way, because we can agree that when there's so much text, skimming through a particular documentation becomes a very difficult thing, because you know that in between all of that text there's something important that you're missing out, which can actually just be highlighted using either listing or using graphics, highlight that particular thing that is of most importance to the user. And then you should also consider the objective writing. Now, we know that you're writing for a particular product that you're on the team. However, you want to write something that both persons that are not in the team, which we're talking about stakeholders, we're talking about persons that are just trying to, maybe use your documentation to create more content, can also utilize this document. So you want to be as objective as possible, not focusing more on the team side to develop your content and make it a universal kind of document at the end of the day. Then you also want to look out for the target audience. Very, very important, because the audience that you're focusing is one thing that you want to prioritize your content on. I already talked about this under understanding the product, but like after understanding the product, you want to focus more attention on understanding the audience. You could do this by doing minor researches to know what the audience is looking out for in this document, or what the audience would want to learn. Reach out to the audience, find out what they know about it or what they don't know, and what needs to be improved. And if the document already exists, go as far as doing like a review on the existing document and see areas that people are having difficulties, spending more time on, using like analytic tools. And I'm sure this can actually be captured using some analytic tools, where you know how much time a user spends on this particular document and how much time they spend on this document, if they found this area of the document a lot more useful or if they didn't. Capturing all of these details will help you better understand areas that need to be improved in your technical documentation. And then, as a technical writer, you should also consider detailed test plans. Now, these test plans come in various forms, which could include can be discussed under the ways we can evaluate our technical documentation. Now, we're talking about the usability testing. First, you should consider your focus testing. Now, what is focus testing? This is simply, reaching out to a group of persons, either on the team or group of persons that have used documentation before. Have a call. You know how they do like book club, where everyone comes together and everyone like sits on a round table. Tell me what you know about this book. Tell me what you know about this book. This is exactly what focus testing is talking about. You put these groups together, and then you ask every person, what is your perspective on this documentation? Did you understand it? Is there a way that we could improve on it to make the experience a lot better for you? And if there is, how can we implement that? You can also consider like the written questionnaire, where you draft out like forms and surveys, sending out to individual users that have come across this document and asking for their feedback from the documentation at the end of the day. Now, this might take a longer time compared to the focus testing, but at the end of the day, you might get really reasonable feedback from these surveys that will be helpful towards implementing your product documentation. And then consider one-on-one interviews. This simply means reaching out to each of these individuals that have used this documentation or are currently using your product, and having one-on-one conversations with them specific to that documentation on how it can be implemented and how we can better improve on that documentation. Now, after all of these results from this test are carried out, you can interpret and then record this data in a way that you share with your teammates and every other person that can work towards improving that particular documentation, as well as the engineering team. Because one experience that I had while working on a technical documentation sometime back was I was able to, reach out to the engineering team because they better understood the product than I did. I reached out to the engineering team, and whatever it is that I wrote, I shared to the engineering team first, to make sure that yes, everything was in order before sharing it to the marketing team to be sure that okay, everything looks good, and then I shared to the entire community to be sure that everything was like in order. So you can also consider sharing with the engineering team as well as marketing to make sure that all of your points and everything is as it should be. Then you can implement the recommendations, implement these recommendations that you've received from the test series of tests that you've carried out by improving areas that need to be improved, taking out portions that are irrelevant based on the feedback that you've received, and also elaborating on areas that are not as elaborate as they should be. And then go on to retest this. After implementing all of this, you can go on to retest these measures with for more effectiveness. Now you can carry this test out as many times as possible until you're sure that at the end of the day you have a really good refined documentation that users can bank on without having to run to your YouTube videos to first understand what the tutorial masters are saying before coming back to your document. So you can also move on to provide means to retrieve feedback even after all of these tests are carried out. You can also like provide a space on your documentation for feedback based on from the user's point of view. So whenever a user comes to your page, let's say they look through your documentation and there's a particular portion that is missing, or there's a particular area where there's a broken link, the user can easily just draw your attention there by writing a brief feedback for you to go much later and then effect the changes that are necessary. And then, so why should you consider evaluating a documentation usability? Well, for so many reasons. First, the product reliability. Now, documentation is one key onboarding tool for product adopters, users, as well as contributors in terms of open source projects. And so you want to have a usable document, or you want to evaluate your documentation for its usability, because at the end of the day, readers as well as users are relying on this particular document as their key onboarding tool, because you don't want to be reaching out to every single person that comes across your documentation, having one-on-one calls with them, doing demos with them, showing them like, oh, sorry, this is what we meant in this particular document. Don't get us wrong, this is what we're trying to explain in this particular document. And so having a good and usable documentation actually helps to determine your product reliability, and it's a lot easier to reach out to the audience and convert users from when a product has high quality documentation. Another reason why you should consider evaluating your documentation for usability is for the user's experience. Now, to be sure, you want to be sure that a reader can quickly accomplish their goal that they're coming to your documentation for. And what is this goal we're talking about? Your users want to know, what is this product? Why does this product exist? How does this product help me? And if they find out if how it helps them, where can they start, or where do they begin? And you want your documentation to actually be able to provide these simple answers to these questions in a very short period of time and improve on the user's experience. And you want to confirm that your document can help a less informed audience to adopt your product at the end of the day, so they don't jump onto the next product because your documentation was not detailed enough. I know so many persons that have come back to say that they wanted to adopt, or they wanted to integrate a particular API, but then going through the documentation, they became so confused they had to go for an alternative API. And not only for API. So many other products that people have come back to say the reason why they didn't use this particular product is the documentation was really difficult to break into. And so you want to consider all of this to make the user's experience as well as the product reliability of more standard. And at the end of the day, I want to conclude this section by simply saying that an accurate technical documentation does not necessarily equal a helpful technical documentation. Now, why do we say that? If a user does not find your documentation usable at any point, or there's a point where they don't find the documentation usable, they're going to move on to the next product or the next project that has a better documentation, and life goes on from there. So we should all take into consideration evaluating our technical documentation every now and then to make sure that it is usable not only to us as members of the team, but also to the audience that are going to be utilizing the documentation at the end of the day. Thank you so much for your time. And that is all that I have for this section. If there are any questions at all, I'll be happy to take that. If not, you can reach out to me through any of the social media platforms, on Twitter at LinkedIn, as well as GitHub. Thank you so much.
Amazing, amazing. Thank you very much for that one, Anita. You could see the excitement. I've had to interact with Anita several times in the community. Of course, she's from Nigeria. I am as well. And, I know that Anita is very skilled at this thing that she does. So thank you very, very much. You can connect with Anita on social media. Like she said, if you have any questions, please reach out to her. Thank you once again. Rob, do you have some comments on that?
I do, yeah. So actually, if you look at Anita's talks when HashiTalks Africa first started to be a thing, and you look at all the talks as she's progressed until today's talk, you can actually see the growth. I definitely encourage you to go back and look at her previous talks. It's amazing. As she was speaking, I was just thinking, I remember the Anita that I saw in her first HashiTalks and how she's grown so much. So yeah, I really love it. And that's the other great thing about this platform is not only do you get to share with the community, but you get to grow your skills in public speaking. So that's a really, really great testament. Yeah, let's introduce our next speaker. So we have Mamadou, who is going to be talking about Terraform in CI/CD pipelines. And Mamadou is a DevOps engineer with over 4 years industry experience, and he's worked on quite a few projects. So interesting to hear his take on this. Over to you, Mamadou.
Thank you very much. Thank you very much, Ban, for the intro. My name is Mamadou. I'm a DevOps infrastructure engineer at CloudKite, and at CloudKite we basically help organizations transform into cloud-native infrastructure, where we basically test stories from legacy, migrations, and of course optimizations of different environments. I'm also a cassava farmer. I run a little farm where I farm cassava. For most of us that don't know what cassava is very opinionated word. It's one of the most popular food source in Nigeria and Africa as a whole. And yeah, if you want to connect with me, you can connect with me on Twitter, and of course active on LinkedIn as well. And today I'm going to talk about Terraform in CI/CD pipelines. But before I start, I'll give you a backstory of how this topic has basically evolved. So initially I wanted to do a demo with either GitHub Action, Flux CD, or GitLab. But then I took a look at other topics, and I noticed that most people, some of the topics are also going to talk about CI/CDs, and I decided to go the uncommon way, which is to talk about security standards, pipelines, and of course Amniotic standards. And for most of us that have experience with Terraform, we know that Terraform is a very strong, opinionated tool, where you if you come across two different companies that are using the same Terraform strategy, then there is a high probability that there was knowledge sharing between the engineers in that team, or an engineer switched companies and then implemented the former practices in the new company. So straight to the objectives, intro, which I've already done, and then I'm going to start with common practices, which previous speakers have already done justice to. So I'm just going to add fun to it and then talk about it. And of course, we're going to talk about code management, where we'll get to talk about monorepo versus polyrepo, poly or multi-repo. And then we're going to have a decision diagram where I walk you through different considerations that you have to consider when you want to implement CI/CDs for your Terraform IAC code. And then if there's time, we'll get to talk about different workflows, like different Git workflows generally. So I believe I've done the intro, so let's move straight to the common practices. Common practices, first one would be the use of remove state. A little backstory again. I had an engineer that was working under me one time, and he mistakenly deleted our backend file for Terraform, and like, of course, he created a pull request, and then the CI/CD was running, and then the environments were creating themselves like from scratch, and then it kind of freaked out because like the state file, remove state file, is very important whenever you're talking about automation and basically working cross team and using CI/CD. So first thing you have to do when you want to like talk about CI/CD pipelines is using the state file, and from there we'll move to the use of dry method. Dry method is do not repeat yourself. The key benefits of Terraform is basically having like your infrastructure as code in one place, having a single source of truth generally for your infrastructure, and always making sure that there is uniformity within the environment. And trust me, it becomes complex if you write your Terraform code and then you have to like write resource blocks for each and every resource that you create. And then at the end of the day, if you want to make changes for like different environments, you'll have to start opening different files and then opening different files and then making changes. And it ends up in having like this, having like configuration drift between this environment. So it's advisable that you always adopt the do not repeat method. And to adopt do not repeat yourself method, you can use modules, which is like the most popular, and then of course the use of a TFVARs, whereby you have different TFVARs for different environments, and then if you want to change anything in any environment, it should be in the TFVARs and not like having to create a resources for a new resource block for that particular resource. And of course, the previous speaker talked about using tags. Tags are very important. They cannot be overemphasized, especially if you work in, like, if you have a good monitoring set in place to monitor your infrastructure. And basically, like, it helps you like track down your infrastructure easily and to monitor and have your basic SLOs and SLIs for your infrastructure. And of course, the most important one that I always tell people that I get opportunity to talk to is don't build for yourself. Terraform is like very interesting tool to work with, especially if you start understanding the data structures, the maps, the maps of maps, and what have you. And it gets really tempting that there's a thin line between building infrastructure for yourself and building for the team. Like, there are some infrastructure that if I want to build infrastructure for myself, it's going to take somebody that is also familiar with Terraform. It's probably going to take that person a few days to totally understand what I'm building. So if you're building Terraform, if you're building your infrastructure, you should always consider your team members, like everybody in the team, and of course developers themselves, because not everybody is as skillful as you. And of course, on a light note part, it is not successful until you apply it. This is like very common, and it can be annoying sometimes, but then it is what it is. So that's all for the common practices. And if you have common practices as well that you do over at your company, you can add it to the comment section so that others can also get familiar with them. And yeah, moving to code management. So as far as CI/CD pipelines are concerned, like the way you structure your CI/CD pipelines is highly dependent on how like you manage your code. So of course there is the monorepo approach where you basically have like all your infrastructure in the same repository. Well, not all the time. There are scenarios where you have like specific infrastructure, like you have your IAM or VPCs in a different repository, and then all other infrastructure is in one repository. So that is more or less like a monorepo approach. And then there is a multi-repo or polyrepo approach whereby you have dedicated repositories for a certain group or specific resources. And this is mostly common in a distributed team where we have want to implement like the shift left methodology, or of course self-provisioning, whereby the infrastructure engineer does not have to get involved in any provisioning of tools, whereby like developers are also familiar with Terraform, so everybody is responsible for their resources generally. And yeah, so you might be wondering why like I'm boring you with code management basics. I mean, it's common, right? But like what's like the basically the permission you give, because Terraform to be able to provision resources in your CSP, like cloud provider environment, you need to give it permission. And the permission you give to Terraform is highly dependent on your code management strategy. And like in most cases, if you're using a monorepo, you give Terraform escalated privileges. For instance, if you have a monorepo where you are creating identity access management, and then you are creating like servers, and then you are creating VPCs, and of course databases, you are basically going to give more or less admin access to that Terraform, to Terraform, and then Terraform can be able to do and undo. Now imagine Terraform being able to create users, Terraform being able to change users, Terraform being able to generate keys and what have you. So that is like a basic overview of the kind of power you give to Terraform in the monorepo. And of course, in the multi-repo approach, you tend to break down the permission to list privileges. For instance, if you have a repository that is dedicated to databases, you give Terraform only the permission required to create or to update databases. And then if you have one for S3 buckets, you just dedicate a list privilege permission to it. And like basically everything is like that in multi-repo approach. So I like to give, like most times I like to give image representations of the power that Terraform has in either monorepo or polyrepo. And first one is, I'm sure most of us are familiar with this face, Hawkeye, Marvel character, superhero, but
Okay, sorry about that, folks. Some technical difficulties. I think there's some internet connectivity issues there. If you please bear with us for a few minutes, we should be able to bring our speaker back, fingers crossed. So just bear with us. Awesome. Sorry about that, folks. Mamadou, we are so glad to have you back. The internet strikes again. It happens to all of us. Awesome. I hope that didn't interrupt your flow of presenting, and the audience. Apologies for that. But yeah, we'll hand it back over to you to continue.
Yeah. So I'll need someone to tell me like where I stopped, because I wasn't like I wasn't taking note of where like my presentation stopped.
I think it was at this point here.
Yeah.
Oh, okay.
Talking about Avengers.
Yeah.
Yeah. Okay. So basically, like I was saying, Archive, like as a security, if I'm a hacker, are basically nothing without my arrows, which is like the permissions, and of course we have Scarlet Witch. Another opinion of mine, Scarlet Witch is the strongest Avengers. I mean, so basically in a monorepo where you have escalated privileges. Sorry, hold on. Okay. In a monorepo where you have escalated privileges, you have the Scarlet Witch who can do and undo. So basically, an attacker can easily get access to your Terraform. Basically, anybody that can create a pull request in your Terraform repository can get everything that is to like attack you. For instance, you can write a Terraform script to extract output from different resources for databases and what have you, and before you know it, somebody has attacked you from the databases to get your passwords, and of course, person can even delete your resources. So that is what Scarlet Witch can do to your resources if you are using a monorepo. But of course, for Scarlet Witch to have access to your secrets and everything, you have to give it access. So basically, that is the picture representation that I always use for this different code management approaches. So when should you use code management, like the different code management? But it depends, because you cannot, like, because of one or two reasons, just move to multi-repo or monorepo. So you have to, like I said, you write code for your team and not necessarily for yourself. So first thing first is if you have a single team ownership, like you have a dedicated infrastructure team for your resources and they are always available, you can use a monorepo for your infrastructure. And of course, if it's a distributed team whereby we have different teams responsible for their own resources, of course, multi-repo comes in place. And then if you want a single source of truth for all your infrastructure as code, monorepo is there. And of course, like if you want granular access and what have you, you can use a multi-repo. And basically, like this is like a monorepo example, and it's like basically like you have your Terraform code, and then this is AWS. So for those that are not familiar with AWS, this is AWS, and the way like this structure works is that there's a control account, like the AWS organization, and then there are other resources in other environments, like we have your dev environment, you have your product environment, you have your stage environment. But this is this folder is dedicated to the control account, which can also be called the master account, where you provision instances like the org, you create the account, the identity access management, the cloud trail, and of course other security measures and other things that you want to put in place. And then there is a folder dedicated for databases, and then of course the shared resources like VPC, identity access management for it, the different environments, and of course EKS, for instance, Kubernetes service, ECS, and of course EC2s and Route 53 and what have you. So this is basically like one of the sample of a monorepo, because like I said, Terraform is a lot, like it's highly opinionated. So there are different approaches that you can use to run your monorepo. In fact, there are countless approaches, but this is what works. This is what works for me, and of course, it does not necessarily mean that it works for everybody. Like I said, if it does not work for most of my team members, then we'll have to look for a way out. So a way to fix it. And of course, to the next question, which is, do you really need a CI/CD pipeline for your Terraform? Well, this is more like an anti-pattern to the topic because, well, I'm talking about CI/CD pipeline for Terraform, and I'm asking you, do you really need a CI/CD pipeline for your Terraform? And I'll be honest with you, not in all cases. Like, you don't need CI/CD pipeline for your Terraform if you are a very small team. Like, for instance, well, the decision tree, we're going to talk more about this, but like a simple answer for it is that you don't need CI/CD pipeline for your Terraform. You don't always need it for your Terraform. And of course, this is my decision tree, and I'm going to walk you through it to like arrive my decision basically. So you've got Terraform, yes, and you want to use CI/CD. If no, then you can apply locally. And basically, if you're a small startup and you're not scaling yet, and you just want to provision basic resources, maybe you want to start with like an MVP for your product, you most likely don't need all the Azures of CI/CDs. So all you have to do is basically apply your resources manually. Of course, you can apply your resources manually while still using a remote state. So this is more or less like for a small team. And of course, if you want to use CI/CD pipeline, is it a monorepo? If it's no, which is like a multi-repo, no brings you back to the multi-repo approach, you are allowed to use your CI/CD pipeline irrespective of the CI/CD platform that you're using. So basically, like I told you, it's like the attacker or anybody is like an Hawkeye. So you have limited, least privileged resources that if there is any leakage in the nearest future, which has not happened to me, but of course in security-wise, you also have to consider worst case scenarios. So if there are like exploitation of your CI/CD platform generally or secret exposure, you know that the attack surface is not on the high side. And of course, if you are using a monorepo, then there are a few questions that you have to ask yourself. Is it self-hosted Git? If it's not self-hosted Git, for instance, at CloudKite, we strongly advise against using like not hosted, like having your CI/CD platform for Terraform on platforms that are not hosted by yourself because of how should I say, how dangerous it can be if your secret gets exposed. For instance, if you have your GitOps action set up and you have your monorepo, for instance, and then you have admin privileges to the monorepo, what if GitHub gets hacked? That means everything about your resources can be pulled down like at the snap of a finger. Basically, Scarlet Witch can just grab your infrastructure and just pull it down. And of course, you can do it, but then of course, just know that there is risk involved. And of course, if you have your self-hosted Git, then like use your CI/CD pipeline for instance, I've worked on a project where we had our own self-hosted GitLab, and everything, secret management, everything was done the GitLab way, and of course it was not exposed to the public. So secrets were more safe in that kind of environment, and of course CI/CD pipelines run for Terraform. But if it's like a platform like GitHub Action, where you have like an admin secret access key in the public domain, it is very risky and can be like very like dangerous to like the organization as a whole. So, but if you still want to go with it, if you still want to set up your CI/CD platform for CI/CD pipeline for, say, let me just use GitHub Action, since I've been using GitHub Action for a very long time. So you can make use of you can make use of the GitHub Action and accept the risks that are involved with like possible hacking and of course dangers of exploitation of your infrastructure. Or you can use external tools, and so external tools like Terraform Cloud. There is Atlantis, and then we have the MFO and a couple of other tools. And these tools were built with the vulnerability of having your keys in like Terraform generally, in CI/CD pipelines generally. So talk about Atlantis, for instance. For Atlantis, you self-host your Atlantis in your own environment. You supply the keys, and everything is secured. So you now connect Atlantis to your GitHub Actions, and for every pull request, Atlantis run your Terraform plan and then does what it does best and what have you. So in that way, your plan is secured. Same thing with Terraform Cloud. You basically have your Terraform Cloud is not like self-hosted, but then you can also is more secured compared to GitHub Action. And of course, the ultimate one is if you still have to go through this decision document and you don't necessarily have any need to automate your Terraform, you can still apply locally. There are a lot of benefits that comes with applying locally, because it generally reduces the attack surfaces of like the permission gives to Terraform, and of course it also gives you like limited access to the resources generally. And of course, I still have a few minutes more, which we'll likely talk about a few cases. Like so, one of the about deal in Terraform exploitation has to do with basically Terraform state, right? Terraform state is where you store everything about your infrastructure, and if somebody that has access to your repository is able to write a Terraform code, to add a Terraform code, especially if your workflow involves the use of PRs, whereby plan runs for every PR that you pull, and then of course like basically if you put your code there, you can basically run an output that generates like everything that you need to attack an organization, from knowing the keys, which of course Terraform has solved partially with the secret feature, and of course also accessing other different resources, and of course you can also delete resources just by pulling out outputs, and of course doing what an attacker will do. I'm not a security, I'm not a hacker, but then I'm quite familiar with stuff like that. And with this decision tree, I hope I've been able to like preach you on like basic considerations that you have to put into, that you have to consider if you want to adapt, use the CI/CD pipelines for your Terraform. And if there are no questions, I expect questions, and if there are no questions, this is like the end of my presentation. Time will not allow me to go in details about other workflows. So Yeah, so thank you very much. This is all I have for you. So are there any questions?
So thank you very much for that talk, Mamadou. Yeah, I learned something from that one. I particularly have used Atlantis in time past, and I can understand and relate with your talk, especially. So thank you once again for that. I don't see any questions at the moment, but of course you can feel free to check on YouTube in case somebody else, has some question later on. Thank you once again, Rob.
The question I have is cassava or no cassava? Well, what is your verdict?
Wow, that's interesting actually, because myself as well, it's something I'm looking forward to doing, farming in the long run. Yes.
Definitely, definitely. Okay, let's move on. We are getting towards the end, but we still have a few more. Lined up for you. So it's my pleasure to introduce to you Damiola. Damiola is a cloud engineer and is going to discuss deploying VMs to Azure using Terraform. So over to you.
Hello, everyone. Welcome here. My name is Damiola Falabi. I am a cloud engineer, a software engineer at Boiler International. I build softwares for web, mobile, desktop, and recently began cloud development. Okay, so today I'll be talking about deploying Azure VMs to Terraform, using Terraform. Okay, initially it was also supposed to incorporate a little bit of Vault, but I didn't have enough time to get around that. So I'll only be restricting this talk to Azure VMs with Terraform. Again, my name is Damola Falabi. I'm a principal software engineer at Boiler International. Boiler International is a software company. We build bespoke software for startup companies or startup solopreneurs who are looking to bring products to the market. Now, given the class of customers that we serve, most customers are looking to build a product or launch a product at minimal cost. Before now, the role as the infrastructure has always been manually deploying, manually configuring VPS, or manually configuring DigitalOcean droplets. Until recently when I got to know about Terraform, which has brought a lot of ease to setting up infrastructure to deploy code to deploy these digital products that these solopreneurs are looking to push to the market. So in this talk, I'll walk you through Terraform key concepts. This talk is majorly focused at beginners. I would like to, share my knowledge to software engineers like myself who are in the habit of manually, setting up infrastructure, to be able to ease their infrastructure setup and also reduce their deployment times. Okay, so first I'll be talking about a few Terraform concepts. Next up, I'll go ahead to discuss the basics of deploying a VM to Azure using Terraform. I'll do a little bit of code walkthrough, and then we'll go on to the live demo. Then we'll discuss best practices and considerations. Okay, so let's dive in. So Terraform key concepts. Terraform, as I've come to know, is an infrastructure as a code tool, meaning it allows you to define exactly what your output should be, as opposed to having to manually state every flow of creation. Okay, you only define the desired state, as opposed to manually imputing or manually laying out the workflow for every infrastructure. Okay, and it uses declarative configuration. Okay, using the HashiCorp language. Okay, which makes it again easier to, what I say, do all of these things. And one of the cool things I love about, I've come to love about Terraform is the fact that it is cloud agnostic. Okay, meaning it has a large provider ecosystem. So whether you're building for Azure, you're building for Google Cloud or AWS, it has a very, very robust provider ecosystem. And on top of that, it automatically manages your state. So after defining either the size or the type of networking or the OS configuration that you would like for your VM or for infrastructure to have, you could just go ahead and change that. And Terraform behind the scenes stores that state and just does the work required to get you from where you are to where you need to be. And you don't have to worry about how much size difference you need to add, what it would require to move the storage from one place to another. All you need to just do is just define the final results of what you need, and Terraform handles that right out of the box. So the basics of Azure deploying a VM to Azure using Terraform. First, you would want to define your Azure credentials. Usually, you do that using by getting your keys from the Azure portal, or you could use the Azure CLI to log in and retrieve your subscription keys, your subscription ID, your tenant ID, and your secret key. Then you want to define the resources needed to create your Azure. Typically, out of the box, before you can create a Azure VM, you need to define some specifics. So I'm going to be sharing, this is the Azure portal. Here, when you go ahead to say you want to create a VM, hold up. Yeah. When you want to go ahead and create a VM, there are a bunch of fields you need to specify. The virtual machine name, the region, availability option, security type, image, VM architecture, and a lot of other fields, depending on how specific you want to be. Now, imagine you are a software developer and you have a code you like to probably push to a Linux server to test, or you want to run on an Ubuntu server, and you've written the code and you need to just put it online, and you need to come here and fill all of this. It gets tiring. You tend to lose your flow. But imagine rather than that, you already have a template file written in Terraform, and all you need to do is Terraform init, Terraform plan, and Terraform apply, and it creates that resource for you right out of the box, like fluidly, and you can go ahead and change the configuration files, and it updates that for you when you do Terraform apply. It just makes you want to build more software, makes you want to deploy more software. So again, I'm addressing this from the pain point of software developers like myself who are looking to minimize deployment time. Most of the speakers that have spoken past have given what I say a low-level overview, expert-level overview of what Terraform and other HashiCorp products bring to the market. And I wanted to dial this back a little for the newbies or for the noobs amongst us who are what I say seasoned software engineers, but are what I say foreign to some of the core benefits of what Terraform does for brings to the software development space for software engineers or cloud developers. So back to my slide. Okay, so yeah, go back. Yeah, so I spoke about right now. I'm talking about the basics of deploying a VM to Azure using Terraform. As I've shown you on the portal, there are a world of configurations you need to make. Now imagine you have to do that like 3, 4, 5 times a day. Say because you want to have different test environments. It makes your work typically you would probably have a DevOps engineer handle this. But for small scale startups, like I said, for solopreneurs who are looking to launch products to the market, Y Combinator will call their kind of product a weekend startup. And for those kind of teams, this is a very useful tool to actually use to deploy, to architect infrastructure, to deploy infrastructure in little to no time. Okay. So, yeah. So, what do you need to deploy a VM on Azure? You need a resource group, which acts like a folder to encompass every other resource you'll be creating. You need a virtual network. You need a subnet. You need a network interface card, which acts as network connector between your VM and the world. You need a public IP address that would allow you access the VM. You need a network security group, which helps you cluster your security. You need OS disk. What is the size of the disk space that you are allocating to your VM? And what's the OS of the VM that you are deploying? And what are the user credentials that you'll be using to access this VM? I imagine having to, define this over and over again from the Azure portal. It gets, frustrating for developers. As a developer, my experience with development, it's cooler when I can just write my code, test it, maybe on my local machine, and then git push, to GitHub and feel like, okay, I'm done. Now imagine having to leave all of that and go to a Azure portal and begin clicking to create VMs. It gets it breaks the flow. But with Terraform, you can easily do things like create VMs, test your code, push your code onto it, test it, and destroy the VM in little to no time. So next, I'm going to do a code walkthrough for all of these things that I've mentioned, and show you what it actually entails to create a VM in Azure. So yeah, try and increase the size of this. Okay, so this is pretty basic. So this is pretty basic. Again, I've included, I need this to be as straightforward as possible for new the software engineers who are looking to enter this space, this infrastructure as a code space, as a way to further streamline their deployment or their time to market or their code testing. Okay, so first, like I said earlier, you need to get your subscription ID and your tenant ID, okay, which I've done here, and I've populated this. So Azure has, Terraform has a thing called providers, where it has where it packages everything it needs to help provision your resource with a particular cloud platform. You know, again, there are lots and lots of different providers that you could explore. And from what I learned from what one of the previous speakers said, you could also create your own custom provider to work as you see fit, which I feel would be a very, very juicy thing to do for a software developer. Yeah. So first, I'm using the Azure provider. I've defined my subscription ID and my tenant ID. Here under the features, I've stated that usually when you try to delete a resource group that has content or has resources in it, you might get some error. So I've stated this flag that prevent deletion if it contains resources. I've set it to false. So once I'm done creating this resource and I go ahead and delete it, whether the resource group contains resources or not, it's going to allow me delete it. So based on the list we have earlier, we need to define our resource group. Again, the resource group is the folder, or it's like acts like a folder where all resources are going to be put in. Your network card, your VM, your disk, and everything tied to creating the VM. Okay, so you can think of this first part, this resources, as what I say, creating a recipe towards the final meal. Okay, so the first recipe, if cooking is your thing, maybe salt, pepper, and until everything comes together into the pot, which is the VM itself. So here you have the resource group. I've stated the name of the resource group and the location, which is West US. Okay. Here I'm defining on the next side. I'm defining the virtual network. I'm giving it a name and an address space as well. And we're using the location that I created the resource group in. Okay, and also defining the resource group has a best practice as a way to tag all the resources that I'm creating for this VM. Next up, you create the subnet. I'm giving the subnet a name again, and also tying it to the resource group and the virtual network that I created previously. Also, I'm giving it address prefixes. Then next is the network interface. Network interface, I'm giving it a name, tying it to the same location that I created the resource group in, and also tying it to the resource group that I created. And as opposed to typing out or repeating myself by typing out the name of the resource group, I'm referring to it using a variable namespace. Okay, as you can see here, Azure RM resource group dot example dot name. Okay, and right in that network interface, stating the IP configuration as internal, stating the subnet ID, and the private IP address location as dynamic. Okay. If you wanted to access this as from a browser or from over the internet, you would want to define a static IP, you know, so that maybe you deployed an Nginx server on the VM, or maybe an Apache server on the VM, and when you define a static IP, you are able to access the VM over the internet. So having created all these recipes, which are the resource group, the virtual network, the subnet, the network interface, it's now time to create the virtual machine. So in the virtual machine definition code block, I'm defining the name for the virtual machine, which is AZ demo VM. I'm using the same location as before from the resource group using the namespace, stating the resource group name as well, using the namespace, stating the VM size, and defining whether or not to delete the OS, OS disk on delete, or deleting it on termination, or on terminating the VM. Here I've gone ahead to define the storage image, the publisher, the author, the SKU. These are what I say things you find on. You can find this on the HashiCorp registry, and also you can also find it on Azure Azure storage list. You can query that using the command line, the Azure CLI. Yeah. So up next, creating the storage OS disk. I've defined the name, defined the caching system, the create option, the manage disk, the manage disk type. Now the OS profile, the computer name, the admin username, the password. As you can see, I've defined the generic password and the username for this VM I'm trying to create. Okay. So OS profile, Linux configuration, disable password authentication false. This allows me to log in using the username and password, although I won't be doing that here. I will only be creating the VM, showing you on the portal that the VM was created, and I'll go right ahead to destroy the VM again. Okay, so here, which is the last line, the network interface we've created earlier, which was this resource. Trying to pull it up. Okay, here. So the network interface we created here, we've also pulled it into the VM configuration. Okay, so in this folder structure, that you see to the left here, there's only one file. Every other file was created when I ran Terraform init. So there are basically 3 steps to doing this. 3 steps. I try to what I say, not overcomplicate it. So first, I created a folder, Azure VM, and in that Azure VM folder, I created a file, just one file, Azure VM.tf. And in that file, I defined all the configuration I need for this VM to work, or for this VM to be created. And then I ran Terraform init. By running Terraform init and Terraform plan, it creates some of this. It created some of these files that you now see to your left. Okay, so Terraform init is how you initialize Terraform. So when you run Terraform init, it goes ahead and gets all the configuration, all the queries the provider, and gets everything it needs to run what you've stated. When you run a Terraform plan, it goes out to plan out your configuration. It goes out to plan out your deployment. Remember when I said earlier that it takes you from where you are to where you need to be without you having to worry about the distance in between. So when you click Terraform plan, it just evaluates it. Okay, earlier you had a OS disk that has storage size of 40 gigs. Now you've updated it to a storage size of 120 gigs. What do I do? Terraform thinks to, so what do I do to get this from point A to point B? Okay, and it does that and shows you the plan. Then you go ahead and run Terraform apply, which then goes ahead and creates the VM. Okay. So in this state, in this demo here, I've already ran Terraform init and also ran Terraform plan. I actually already ran Terraform apply to create the VM, and I've destroyed the VM multiple times, which is actually a cool thing. It's not something you would I say fluidly do from the Azure portal. So next up, I would be showing you I'll be showing you a live demo of this code that I wrote there. So I've been showing you the code walkthrough. I'll be showing you a live demo of this code. So go ahead and present screen. Time window and okay. So like I said, I've created and destroyed the VM. Before I go ahead and run that code, let's take a quick peek at the Azure portal to see what we have there right now. Done. Okay, so the previous screen we had where I showed you all the requirements for creating a VM. So I'm going to go back to list out the virtual machine. So as you can see here, there is absolutely no virtual machine on this account. Okay, so I'm going to refresh one more time. So you could actually see that. So I'm refreshing one more time. That's empty. No virtual machines. So I'm going to go back to my terminal and share screen, terminal. Yeah. Okay. So here's my terminal. I'm going to do an ls so you see what we have here. So this is the Azure VM.tf file, which is the Terraform file. And again, I already ran Terraform init, but for the sake of this demo, I'm going to do that again. Oh, okay, sorry, that's a typo. So initializing Terraform. So it is initialized Terraform. I'm going to run Terraform plan. Right now it's planning out the deployment. This might take a bit. Again, I didn't need to run Terraform plan because I already did that, when I tested the code. But for the sake of this demo, I wanted you to see what that's like. So having run Terraform plan, it goes ahead to show you what the plan would be for deploying the current VM that you have, all the resource that will be created, when you go ahead and apply this plan. Okay, so having done that, I will go ahead and run my last command, which is Terraform apply. That's currently running. So it shows me the plan again and asks me if I'm okay with it. It said Terraform will perform this action described above. Only yes if will be accepted to approve. Okay, so go ahead and type in yes, and it goes ahead and begins creating the resources that I've defined in the Terraform file. So now it's okay. So it's creating the resource group. Awesome. Awesome. So it's done creating the resource group, and yeah. So one of the cool things I appreciate about Terraform is also, again, its ease of use, its cloud agnosticness. The fact that it's not tied to one single provider. Now, for me, who is a ferocious learner, again, I'm a software engineer. I started my journey building for web, then moved on to mobile development, web full stack, moved down to mobile development using Flutter and Dart. Then picked up GCP, went on to AWS and Azure as a way to get a 360 view of what it looks like to actually build software, irrespective of what platform it is. Now, if one person had to go ahead and learn all of those things through and through, learn how to deploy softwares for those individual platforms, it's going to be hectic. And it takes the time away from you learning to actually own your skills as a software developer into a shift in career. Okay. So, but one of the cool things that's one of the things cool, that's where Terraform shines. It allows you to use one single nifty tool to interact with this cloud platforms, irrespective of what they are. You just need to know what you need to define, what you need to deploy. Are you trying to deploy a VM? Are you trying to deploy a database? Are you trying to deploy a virtual network? You just need to understand, okay, before I can create a VM on Azure, I need a resource group, a disk, a network, and I just need to just define that. And I can go ahead and Terraform will go ahead and create all of that for me. When you weigh that against tools like platform-dependent tools like AWS CloudFormation or Azure templates, they get pretty much complicated. But Azure is Terraform is pretty straightforward and a very cool tool to adopt. So it's done creating the VM now, and I'm going to switch back to my Azure portal to show you. So share screen, and there we have it. So currently sharing my screen, and from before it's empty. I'm going to refresh that, and voila. We have it. We have the Azure VM I just created, Azure demo using West US, using Linux, the standard DS12 V2, and it's right from my terminal, I didn't need to go to the Azure portal, and it did that for me. It's pretty amazing, pretty an amazing tool to in the hands of developers looking to test software on the go without having to leave their comfort zone and keep their flow, you know. So I'm back on the terminal, and just imagine I'm done with this VM and I want to disperse it. So I'm just going to do two things now. First is I'm going to I'm going to destroy this VM that I just created, and I'm going to recreate it again. Yeah. So you did a project today. You wanted to test it on a VM. Uh, One of the speakers spoke earlier and mentioned Packer. Amazing speakers earlier with proven experience in the field, showing high-level use cases or expert-level use cases. Or now you could actually extend the use of this tool. Someone spoke about Packard. Someone spoke about Vault, which is pretty inspiring to work with. So I'm going to go ahead and destroy this this VM, and then go ahead and recreate it again to show you how easy it is to create, destroy, and recreate a VM in less than 5 minutes. Now, but if you had to do that from the Azure portal, it's going to be hell, because most times you are wondering, okay, what's this name supposed to be? What's that name supposed to be? What name did I use last? What password did I use last? What username did I use last? And because you have a template already, you can just use that same template to create and recreate multiple VMs by just changing some variables here and there. So right now, it's currently destroying. Okay, I believe it's. Oh, I don't. Share my screen. I think I need to do that again. So, okay. So I go ahead and type in. I'm not sure this is working. Hold on. They lost me. Hello.
We can hear you. You can go ahead and continue. Your screen is up.
Okay. Oh, great. Okay. So, yeah, I typed in Terraform destroy, and it has laid out the resources that are going to be deleted. And yeah, I get a chance to review it one last time. And before I go ahead and type in yes. So upon typing in yes, it'll go ahead and begin deleting the resources. So here you can see it delete resources that I've created. All resources tied to the VM that I've created. And this would only take a minute or two, and which again expresses the fluidity, the power of this nifty tool that we can just that developers can, what I say, exploit to ease their development workflow. So while that's been done, I'm going to jump into, okay, I'm still sharing the screen, so I'm going to allow it finish. So it's destroying the resources that's destroyed the network interface card, still destroying the network, I believe. And this is one of the cool things that what I say developers would love. It's more like, it seems like probably updating your PC or what I say running brew update or apt-get update, and they don't have to go ahead and click, or they need to just do is run a command and allow Terraform work its magic. It's, again, I can't stress this enough. It's amazing. So while this is going on, I want to go ahead and talk about the last part, which is best practices and considerations. Okay, so although I wrote this code in, oh great, it's done, and that only took 1 minute 25 seconds, which is a so little time, and then I could go ahead and create the same VM again without having to retype the code or go back to the Azure portal to do any of that. So last part I want to talk about is best practices and considerations. Okay, so yeah, demo, best practices and considerations. So one of the best practices of using Terraform, as a lot of speakers have laid out earlier, is first off, you want to, would I say, separate your variables from your core files. Next up is a lot of speakers or use cases, I see them pushing their state file to a bucket. So a bucket so that developers who are collaborating on the same project can have access to the state file, and what I say, have access to the same resource that you've created, or the current state of the resource that you've created. And again, that's great for on a large scale, but here I'm talking about small teams, a team of 3, 4, 5. Usually in countries like mine in Nigeria, most new developers or intermediate developers still share source code and configuration files via WhatsApp or Google Drive, and that's not the best practice. But by either using GitHub, committing to GitHub, and using storage buckets, they can easily streamline sharing this resource. So first off, separating your variable files from your core files, it allows you make changes to your code from one central place. Secondly is cloud-based state files, sharing state files in a way where so that developers can have access to, would I say, the current state of the machine you are testing with. And one final cool consideration I would like to touch on for I would like to employ developers working for solopreneurs and small startup team is, aside Terraform, I would really implore you to explore the use cases of Packard and Vault, like many experts have spoken about today in their various sessions, using Packard to configure and deploy on after infrastructure as code, after Terraform has done its work, and using Vault to rotate keys and manage secrets. Makes first off, eases your deployment. Number two is it creates a standard of practice for the innovations that you're trying to usher into the market with these solopreneurs. I hope this has been quite informative for you as it has been for me. And I hope you learned a thing or two about Terraform from this. Thank you very much. So I'll be in the comment section to take questions that you might have, because I see that I've used up a lot of my time. Again, thank you very much for having me on this talk.
Yes, indeed. Thank you very, very much, Damilola, for that walkthrough. I believe a lot of people in the audience will be able to, go along now with Terraform and on Azure. And like you said, Terraform is cloud agnostic, so Terraform can be used across a wide range of cloud providers. So thank you very much. Please check out LinkedIn. There are some questions. I think there's a question on LinkedIn for you and one on YouTube. Thank you again. So Rob, do you want to let us know what's next?
Yeah, sure. But I think before we do, I just want to plug that we have the virtual HashiDays event coming up next week. So register for that. You're going to hear some great talks. I myself am going to be in the London in-person edition. I believe the tickets are sold out. But for the virtual event, we can all attend. So definitely head over to the website. The banner is on the screen, and register your interest there. Yeah, let's move on to our second to last talk for the day. We have Nuno, who is a technical marketing manager, and they're going to talk about Terraform and Ansible and how they're better together. So it's over to you, Nuno.
Good afternoon, everyone. My name's Nuno Martins. I'm a Principal Technical Marketing Manager at Red Hat, and I work specifically at Ansible. And one of the big passions that I have is basically Ansible with Terraform and working with the Terraform toolsets. And today I'm going to kind of dive into the, why do we want to work with these two tools together? It's not a conversation about why one tool is better than the other, but more about how these tools together actually do a lot more, and get a lot more done. So we're going to dive into this. I'm going to show you the latest Terraform provider as well. So hopefully you can see that and see that there's a lot of benefit with these guys together. And let's dive in, right? So if we start off, there's obviously a big debate, at least from one that I've seen. Do we use Terraform? Should we use Ansible? And this is not a debate that's actually needed. This is kind of an old discussion, but really these two tools, although there is overlap, they do different things, right? So Terraform, we know, is really great at infrastructure as code, and lots of people use it for that. Whereas Ansible, we can do things like configuration, we can do automation, we can, do advanced automations in a sense of things like event-driven automation, etc. So these two tools, although they do overlap and both can do provisioning, for example, they actually work best when they're working together. Okay, so first question is, why use Ansible and Terraform? Why use them together, right? Now, we know what Terraform does. Terraform is great. We can go and we can take Terraform, we can build out manifests, we can apply these manifests, if we want to change infrastructure, etc. It's really easy and it's really powerful to work with this. But now, one thing that Ansible is great at is things like configuration. Ansible is great at configuration. Ansible is great at running, automated compliance, things like automating the best practices, making sure everything is consistent, making sure we don't have configuration, scope creep or anything like that, no configuration drift. Ansible is very powerful at doing all of this stuff. So if we put them together, we can actually use Ansible a little bit more, because what we can do is we can get Ansible to build all of these manifests that we typically use within Terraform. And from there, start to centrally manage what we want to do with Terraform. Okay, so, we can go and build the stuff, we hand it over to Terraform. Terraform goes and does what it's good at. It builds all of this infrastructure for us, and it really works well. It saves that infrastructure in these state files for us. But Ansible can then come in afterwards, and it can go do day 2, it can go do those configurations, those security checks, etc. So these two tools actually work very well together, especially on an end-to-end type of workflow. Now, from Red Hat, we released a certified collection specifically for Terraform, and this was released last year. Now, what does this allow us to do? Beforehand, we used to have community collections for Terraform, which would kind of do the basics. But what this allows us to do is we've extended that a little bit further, right? So using the certified collection that we get now, we're able to do things like, create, initiate the Terraform automation workflows. So we can use the certified collection to actually go and do all the plans and the implementations with Terraform. We can automate the management of all of this stuff. So we can automate all the infrastructure as code. So as the infrastructure as code is being triggered and being built up by Terraform, we can actually use the automation platform and let the automation platform come in afterwards to ensure things like lifecycle management, configuration, and just things like cloud hygiene, making sure instances are actually running the way they should, right? Terraform does all of the building for us, and that is where it's really good. Because if we wanted to do the same with Ansible, sure, Terraform can build infrastructure. We could build infrastructure with Ansible too, but Terraform is just a lot easier to build that infrastructure and to bring that infrastructure down. So it's a real key part to all of this, right? So if we're using Terraform to do that, we can get Ansible to do the rest of it, and to kind of do all the stuff that we're going to need post provisioning, post implementation. All right. So currently, the cloud.terraform collection that we have, or that we work with, provides the modules, right? So we have the modules where we can go and we can import manifest files, and we can import the content from a traditional user who's working with Terraform, which is really important, because again, if we go back to the original discussion of should I use Terraform, should I use Ansible, that discussion shouldn't even be happening anymore. These two tools are great, but they work really well together. And if you've already been using Terraform, why do you want to rebuild all of that? Let's just bring all of those manifests in, we import them with Ansible, and we get Ansible to tell Terraform basically to go and build whatever it needs. So this is how these will work, right? So we're able to do that, we're able to build all of this. And something I'm going to touch on a little bit later is we also have a provider for Terraform. So this is really key from a Terraform perspective. But yeah, we'll discuss that a little bit later. So ultimately, our certified collection allows us to, work with Terraform in a certified, supported way. So we have support on it, etc. And this is quite cool. All right, so I mentioned beforehand that we also have an Ansible provider for Terraform. This came out earlier this year. Now, if we look at it from an Ansible perspective, I mean, I'm an Ansible person, I look at it from an Ansible perspective. I centralize everything with Ansible. Maybe I'm running my Ansible platform, and I'm getting Ansible to build my Terraform manifest. I'm getting Ansible to deploy with Terraform and building my infrastructure before handing it back to me, where I can get Ansible to go and configure things and all of that. But what about the people who are actually working quite heavily from a Terraform perspective? So this is where the Ansible provider is really key, because what the Ansible provider allows us to do is inside of our manifest files with Terraform, we can actually specify Ansible inventory information. Okay, so this becomes a resource inside of this manifest file, and we have a plugin, right? So we have an inventory plugin for Ansible. So what happens is I go and I build my Terraform workloads like I would typically do. I put in these details and I trigger Terraform, and I tell Terraform to go and build. So Terraform goes off and it starts to build all the infrastructure. But at the same time, what happens is in the state file that ends up from all of this infrastructure, we now have the resources for Ansible to use. And because we have the inventory plugin and all of that now built, this allows us to seamlessly trigger Terraform, let Terraform do what it needs to do, and then ultimately quickly call up Ansible and tell Ansible, look, this is all of the host information, this is all the infrastructure information, please connect to this infrastructure and run compliance, run configuration, do all of this stuff. So this is a really cool way for Ansible users and Terraform users to work, but largely around what Terraform developers, Terraform users are going to be working with when they deploy their infrastructure with Terraform. It's a very simple way of plugging it back into Ansible and letting Ansible then carry on with doing what it needs to do. Now, if I am a Ansible user and I want to actually work through Ansible, what we're able to do with this certified collection is we can, like I mentioned, we can go and build out all of these files that we need. So we can go and we can build out the manifests that we need. We'll be able to use things like Ginger, which we'll touch on a little bit later. But ultimately what we can do is once we have these files, whether we import them in or we create them, we can then, through Ansible, trigger, the planning and the deployment of this infrastructure. Now, if we're working with Ansible and we're working with things like the automation platform from Red Hat or anything like that, one of the key things here is obviously we can deploy this infrastructure, and once it's deployed, we can actually do things like dynamic inventory. So we can actually go and check our cloud infrastructure to see which hosts, etc. has come up. And from there, we can build our automation workflows to address them later, pretty much like how the provider works, but obviously from a platform's perspective. So this is where we use our certified collections inside of Ansible. We're able to build all of this. We can import the pre-existing workloads and backends that we have from Terraform, and we can get going relatively quickly without having to rehash anything or rebuild anything, which is quite beneficial. So I mentioned Ginger from an Ansible perspective, and this is also really powerful because imagine you're building and you're wanting to deploy infrastructure with Terraform, you want to use Terraform, you also want to kind of build a template, right? So users can actually go and modify certain things and then let Ansible actually build out this template of this Terraform manifest and then get Terraform to do it. So we're able to do this pretty simply using Ginger. And basically what are we going to be able to do? We're able to go and tell these templates, this is the kind of criteria that we want, or this is the information that we need when we're trying to build out. Take all of that information, so when a user goes and decides he wants to go and actually trigger infrastructure, he wants to go and build all this infrastructure, we can ask a couple of questions using things like surveys, get that information in there, and basically build out these files that we need, and then hand it over to Terraform to go and actually build whatever we need to take place from an infrastructure perspective. So this is a great way to again use Ansible with the likes of Ginger to help the Terraform workloads and to build the Terraform workloads, make everything a lot more recyclable in terms of being able to trigger automation, being able to build these infrastructures and bring them down with the ability to customize certain areas, right? So you can still standardize what you want to do. You can still keep things consistent, but giving your users the ability that through these templates, they can actually change certain things that are going to be important to them. So Ginger templates are really, really easy, really powerful to use inside of Ansible in general, but when we put them together with Terraform, then obviously things go to another level. So if we had to look at a workflow of end-to-end, if we were going to put Ansible and Terraform together, this is typically what we call, something like infrastructure as code meets configuration as code. This is a simple thing that we could actually look at, and this is an automation workflow, right? So this is a workflow that's taken outside of the automation platform visualizer, and we can see from here kind of the steps, right? So if you wanted to build a simple workflow, what we would have, you'd trigger off this automation, and you're going to go and ask the users or prompt the users for all that relevant information. What do you want the instances to be called? Do you have any specific configurations like memory, disk size, etc.? All of that stuff then gets taken and fed back into Ansible. Ansible builds these manifest files. It builds all of the files that we need for Terraform, and then it triggers Terraform to actually go and deploy the infrastructure. So Terraform goes, builds that infrastructure, deploys that infrastructure. Then what do we need to do? Well, once Terraform is done with its job and done building what it needs to build, what we can do is then we can use things like our dynamic inventories again to synchronize what's changed from an inventory perspective. But we can also extend automation out further. So we're able to go and do things like log tickets in an ITSM. So let's say you wanted to go and deploy infrastructure, you deploy the infrastructure, you want to know about it. So this is where Ansible can assist as well, and can basically assist you with logging tickets like in ServiceNow or something like that, to say, hey, here's the information. These are the instances, these are the hosts that have been built by Terraform. This is all the relevant information that's happened. This stuff's all up and running, so that your teams are aware of all of this, right? And then after that, Ansible will step in again, and we can do something, a post-provisioning task. So this could be the security, that could be configuration, this could be anything, you know, maybe the infrastructure that you built had a certain role or a certain requirement. Ansible can come and do that for us, right? Now, bringing all of this back down would be a similar process. So all that would happen is, depending on where you kept your state files, you know, we could be keeping our state files in S3, for example. We would then be able to import those state files and get, you know, the reverse going on. Get Ansible to basically tell Terraform, look, this stuff is done, please bring the infrastructure down. Terraform does its destroy, brings the infrastructure down, and Ansible can go and clean up. So Ansible can go and, you know, again, notify people if it needs to be notified. Otherwise, it can go and change things, you know, anywhere else. Perhaps you had network configurations that needed to be cleaned up. You know, Ansible would go and clean that up. So this is a great way to bring all of these tools together. Okay, so again, if we go back to the original discussion, it's never about Ansible versus Terraform. It's about how these two tools actually work very well together. There are certain aspects that, you know, Terraform does very well, and then there's other aspects where Ansible can, you know, really step in. So that's why we say that, you know, these tools are kind of built together, they're better together, and that's how, you know, we kind of should work with them, right? So this is why we enjoy doing it. So I'm going to go now and show you a very simple example. This is using basically the provider. So this is the provider that came out for Ansible that we can run with Terraform. So we would be able to go and we build our Terraform and basically, you know, run what we would typically run. But we now have a way to basically trigger Ansible straight away and get Ansible to come in and do its next couple of steps. Okay, so here we go. We're gonna have a look at this. So I'm basically having a look at my Terraform manifest file, and what I've done is I've gone and I've put in my providers. So I'm looking at the Ansible provider, and I've put in obviously all the other relevant information. You know, I've configured AWS, etc. And you can see here that now what I'm going to do is I've gotten a little bash script, and this triggers all of the Terraform stuff, as well as triggers a playbook afterwards using, you know, the inventory plugin. So if we go and we run this, you know, we're going to go and we're going to build all the infrastructure. It's going to go and it's going to create the state file when it's done. And this state file basically is what we're going to be using with the Ansible provider to go and, you know, feed this information or this relevant information back into my inventory, so that I can go and we can trigger a playbook. So this is really, really useful. And as you can see, everything's being built out, and basically now I'm going to run my playbook. Now the playbook goes and queries the inventory, gets the inventory information or the host information out of the state file, and from there we can actually trigger that. So if we go and we have a look now in AWS, you can see what's happening. I just want to see, we can see the AWS instance is there, and Ansible is now basically configuring this instance, right? It's installing Nginx. So all pretty seamless, and this is just using the brand new provider that we released earlier this year. So yeah, you can go and you can install this provider and basically feed all this information back to Ansible and let Ansible do the rest. So that's how we work with Terraform and the Ansible provider. Okay, so now we're going to have a look at doing this the other way. So using the Ansible automation platform, how are we going to work with this to build out infrastructure, to build out you know, what we want using Terraform, but using it inside of Ansible. So now if we have a look, you've got my inventories here. I'm just going to go quickly and sync my inventories. So I'm going to sync my AWS dynamic inventory. So this will scan everything, and based on filters will build up an inventory for me. So now that we've done that, what are we going to do? We basically have to go and say, okay, well, we're going to go and actually build infrastructure now. Okay, so if I have a look at my host, you can see there's nothing there. Now, if I'm going to go to the jobs, I've got a job already running, so I've gone and I've taken this information, like my name, etc., and I've already fed it into an automation workflow. If we have a look, you can see that I'm going to be creating these components. Now, because I'm not pushing anything to S3 or anything like that, what am I doing? I'm pushing all these state files, I'm encrypting them, and I'm pushing these state files into a Git repository for me to use later, so I can pull them back down and then, you know, re-import them and trigger them off. So if we go back and we look at our automation workflow, you can see what the steps are, right? So I've deployed the infrastructure with that. Now I've got to go and have some kind of approval. I'll trigger an approval step, and this will allow me to synchronize. So, you know, this approval inside of an automation workflow will then synchronize what I want to do, which is the inventory sync. Once that's been done, I've picked them up. Now I move over to the next automation task that I have, which is to update, you know, these instances that we've built, right? So it's now got those instances fresh from AWS inside of the inventory, and from there we're connecting back to them and we install in Apache or whatever we're going to be doing. We're going to be updating, etc. So it's really a simple process, and what I really like using about, you know, this kind of working with Terraform is it makes things really easy for me as an Ansible user to go and build infrastructure in the cloud. And because I put it all into Ansible, I understand Ansible, it obviously makes things easier for me to work with, but I have all the other tools that I would typically use from an automation perspective, right? So I can use these things like, you know, dynamic inventories, etc. So this is from the other side as an Ansible user working with Terraform to quickly build out the infrastructure and basically do the rest of the work that we want or that we would typically do, right? So this is a really nice way to do it. Okay, so we can see that everything is done basically. It's updated, it's done what it's needed to do. And we can go and we can actually have a look at those instances if we want. But, you know, effectively what we're trying to get to is we wanted to get to this point where we use Terraform to deploy with Ansible building everything that Terraform needs. Once that's done, we've gone in now and we've done, you know, post-provisioning configuration. So we've done updates, we've installed Apache and all of that. Okay, so that's quite cool. Now if we have a look, you can see this is what the instance is called. You can see there's the host details from what we've built with Terraform. Now if we go there, we should be able to get to a system, right? We should be able to get to the system because now we've installed Apache. We can see here we go, there's the system, right? And it's all up and running. And yeah, that's a simple way to do it in terms of using Ansible to trigger Terraform to build my infrastructure. Okay, so that was just a little demo of the provider. You can go and grab that provider. You can start working with the provider straight away. These are some of the resources that are out there from our perspective. So, you know, we have a repository, obviously on GitHub you can get to. There's self-paced labs where there is an Ansible and Terraform lab that you can get working. You can play with the two. You can play with it on the automation platform. We also have a number of blogs, so we do push out quite a lot of blogs around these topics, and whenever there's an addition to the certified collection or a change or an update to the provider, we tend to, you know, do a demo and blog about it, just so, you know, people are aware that these things are there, that you can actually go and do them and bring these two tools together. So I hope you enjoyed that, and I hope you got some insight on how these two tools really work well together. And I hope you enjoyed the rest of your HashiTalks. Thank you.
Beautiful, beautiful one there, Nuno. Thank you for coming to HashiTalks Africa. Thank you for that talk. It's not Ansible versus Terraform. It's Ansible and Terraform working together. Thank you so much for that one. Rob?
Okay, so we've moved to our final talk of the event. I'm pleased to introduce Basil along with Yunus. They are going to talk to us about building scalable infrastructure using GitOps with Terraform on GCP. So over to you.
To be here, I'm going to be talking about building scalable infrastructure using GitOps with Terraform on GCP. So let's get right into it. So briefly about me, my name is Basil Ndonga. I'm a senior software engineer at iProcure Limited. You can find me on LinkedIn using that link, though I'm going to let my friend Yunus introduce himself. Yeah, over to you, Yunus.
Hi, my name is Yunus Arif. I'm currently working as a software engineer at iProcure Limited. Yeah.
Okay, so a bit of introduction there. So what do we do at iProcure Limited? So I'd just like to make a brief introduction about our company. So iProcure is the largest agricultural supply chain distribution company in rural Africa. We are based in Nairobi, Kenya. We offer last mile distribution services. And also we supply agricultural inputs to over 1 million commercial smallholder farmers in East Africa. So we have a network of distribution centers in Kenya, Uganda, and Tanzania, and that would mean that practically speaking, our work is to design and implement scalable microservices to support our customers. So that's briefly about what we do at iProcure. So onto the agenda, what are we going to be talking about today? So we'll have a bit of the manual way of doing things. We'll talk about infrastructure as code. We'll do a little bit of lessons we've learned implementing ISC at iProcure. We're going to also, Yunus is going to talk about the GitOps way of doing things. And then we'll have a little bit of a demo. So let me begin by saying that, say you wanted to deploy your newly created backend application. Say you have developed an application on, Laravel or Node.js, or even Python. So you're very excited. You could deploy that on AWS or GCP or Azure. So the old way of doing things, or the manual way of doing things, would look something like this. So you'd go to the cloud console, like GCP or AWS, and then you choose the appropriate server or operating system. The manual way, you probably would need to configure networking. You'd set up VPC, you'd set up subnets, and so on. And then you'd probably spin up a database instance, then set up TLS certificates. You'd probably set up environment variables and all that. And then you'd spend hours on Stack Overflow trying to figure out how to, fix bugs and so on. And then finally, you're happy the application is configured. Okay. So the problem comes when you want to do the same thing again. You've been told you need to deploy the same application you've created across 3 environments. Say you have a staging environment, you probably have a QA environment, and the production environment. So you built the application, but now you need to replicate the same application in all these environments. So this process, as you can see, is already tedious. You have to replicate the same steps that you had done manually. So that brings us to some of the problems with doing things manually. One obvious problem is now the DevOps teams will obviously make certain mistakes where you have, I would say, configuration drifts. One application has been deployed on one environment with a slightly different configuration from the others, just because it's being done manually. And therefore, that would mean you have the same application with a slightly different configuration from the original one. So what we need is a consistent way of having the same infrastructure, the same application replicated in the same manner across all the environments. Another problem with the manual way of doing things is that releases can become very slow, repetitive, and painful. Probably most of you guys here are developers, and this is not something new. You go through the same process, and whenever you're supposed to deploy an application, then everything becomes very cumbersome. So the manual way of doing things is not the way to go. Another problem is outages become frequent. So system is down, you do not know where the problem is, and you'd find that in such a scenario, even setting up metrics is a challenge, and you cannot have a view of where the problem is at the time that issue occurs. And developers will always tell you, hey, it works on my machine. They isolate themselves and put that blame on the DevOps teams. So the reason why I'm saying this is that there's a better way of doing things. What if we told you that we could do it differently to solve some of these challenges associated with the manual way of doing things? So that brings us to infrastructure as code, which is pretty much the idea that you can manage almost everything as code. You could manage database as code. You could manage servers as code. You could manage load balancers. You could manage networks, documentation as code, and all that. So you have this idea that every part of your infrastructure can now be codified, and those best practices are shared within the organization so that every person within the team can understand or have a view of how the infrastructure looks like. So what are some of the tools available out there that can help us automate some of these manual infrastructure processes? So we have Terraform, which we are going to talk about briefly. And then we also have other alternatives. We have Google Deployment Manager, which is a service that is offered by, is a tool offered by Google. We have Azure Resource Manager. We have AWS CloudFormation. We also have Pulumi. We are not saying that there are problems with these tools, but we find Terraform, and even in our company, we found Terraform the most suitable infrastructure as code tool for us. So a bit of the benefits of infrastructure as code. Obviously, you get code reuse. So that means you could write your IAC code in form of reusable module. So you can use the same code across multiple environments. So you'd have an environment for staging, you'd have an environment for production. And using the same code, you can be able to share across these environments. Another obvious benefit is you get documentation. So that means that the entire infrastructure deployment is not stuck on a system admin's head. This information is publicly available to other members of the engineering team, and therefore they can be able to have a glimpse of how the infrastructure looks like. Okay, and then we also get automation. So now the entire infrastructure deployment will go through an automated CI/CD pipeline where you have your developers pushing code to Git repositories, and then those changes are merged to the main branch, maybe through a pull request, and then that will trigger an automated CI/CD pipeline and then deploy infrastructure changes. So today we can be able to deploy not only application code, but we can be able to deploy infrastructure code just using Git repositories, and then that would go through that automated pipeline. You also get version control. So the entire history of infrastructure changes to your Git repositories can be tracked by a version control system. So you have all those changes, and it's easy to roll back to a previous version. That is in case something goes wrong. So I think that is pretty much the benefits, though I've not exhausted all the benefits of infrastructure as code, but using infrastructure as code is the way to go if for companies that intend to scale their applications to production and have a better way of deploying your infrastructure. And then you get collaboration. Okay, now you have several teams. You're working in a large organization, and then different members of the team can be able to collaborate on the same infrastructure code and probably even share the same state. So allow me to take you back to Terraform so that you get a glimpse of what this tool is able to do in production. So Terraform is essentially a tool for deploying your infrastructure code, and it uses a simple declarative language, that is HCL, HashiCorp configuration language. The good thing with Terraform is that it works with a variety of different providers, including but not limited to AWS, GCP, Azure, DigitalOcean, and so on. Plus, there are a number of other providers that are provided by HashiCorp in their public registries. So I'm going to talk about some of the lessons we've learned implementing infrastructure as code, and then go deep into each of those items to explain some of the challenges we encountered and why we went the ISC way. One thing we've learned as developers, even in our current company, is that it's always a good idea to have remote state. So this infrastructure is going to be, this code base is going to be shared by multiple developers. So developers will contribute to this code base. And you do not want, whenever one developer makes a change, that change can overwrite previous changes that were done to that infrastructure. So the best practice is to have a state file that is stored in a remote backend. That way, any changes to the infrastructure is automatically available to other developers who are pushing code to the same repository and deploying infrastructure code. Apart from that, it is recommended that you have multiple environments, one environment for staging, another environment for, say, production, so that you can test some of these infrastructure changes even before those changes go to production. So you have, you are very sure that by the time those changes go to production, you have well-tested, battle-tested, reusable, pieces of your infrastructure, and those pieces have been tested, and have been tested, and they work, probably even in a production environment. Another thing that I probably also mentioned is that we should create reusable modules. So modules are reusable pieces within your code. So that means you could write a module to set up a VPC network. You could write a module to create a storage bucket, probably spin up a GKE cluster. You could write a module to, do virtually anything within your cloud environment, whether you're using GCP or AWS. You can be able to write code that other members of the team can use and share. Then again, it is important to test your infrastructure code. IAC code that is not tested is, well, broken. That's what I would say. So these are some of the best practices we have implemented in our current company. And I would want to now get deeper into state management. So remote state. We probably by now know that Terraform can find resources that it had created because all that information is kept in a state file. If you're working locally, then that would be in a terraform.tf state file. But like we had said in this discussion that we need to have this state file stored in a remote backend so that every member of the team has access to the same state file. So any modifications to the infrastructure will have to go through that state file. So the state file essentially just keeps information about what changes have been applied to the infrastructure, and you can see that information whenever you run Terraform plan or apply. You could view the state file and be able to see changes that have been made and the resources that have been created. So, and by default, this is stored in a local backend in a TF state file, which is usually in JSON format. So this is an example of a state file. As you can probably see here, this is we have a number of resources here. We have the local file resource, and then this JSON file will tell you which version is being used here. This is version 4, then outputs and all that. So all that information can be viewed on a state file. So I've also emphasized that whenever you're working with teams, each person or each member of that engineering team will need to access the same state file. And that is probably the best practice. There are a number of remote backends offered by other different cloud providers, like GCP has a GCS bucket. You can also use S3 as your remote backend, and any changes to your infrastructure will have to go through that state file. But again, other issues come up, like what happens if two developers are trying to make changes to the same state file. So the lock won't be released until one member has that infrastructure code has been implemented. That is when the lock will be released and will be available to any other individual who is also trying to make modifications to the same code base. So this is an example, a snippet that shows you how to configure your remote backend. So you'd specify the name of the bucket, probably specify the bucket prefix. And for us, we give a path to the service account file, so we can authenticate requests to our cloud environment via the credentials resource attribute. So we would be able to provide that. We have the prefix and we have the name of the bucket. So with remote backend now enabled, we can now get the latest changes when we run Terraform plan and apply. So about multiple environments, we have already said that it's important to have separate environments, one for staging, another one for QA, and probably another one for production. So that way you can be able to test your infrastructure across these environments. So this is an example of how you would structure your infrastructure code. You have the environments directory. Within the environment directory, you have a directory for production infrastructure code. We have another directory for staging infrastructure code. Then you have the examples folder where you will store all the infrastructure code that you need to test. So we will explain a bit of tests when we'll be talking about unit testing using a tool called TerraTest. So this is essentially how we have structured our application code. So let me talk about reusable modules. I've already stated that modules are reusable pieces of your infrastructure code. So modules combine resources that you use together, and we can look at a module more like a blueprint of how certain features will be implemented in your code. So the good thing about modules is that you can reuse the same module in multiple environments. So both the staging environment and the production environment would share the same code base. It's also a good practice to have these modules kept in version control so that you can version changes to your module. You could have the production deployment running on a slightly lower version than the staging deployment. So that way you can test certain features, and if something goes wrong, you can roll back to a previous version. A good example of what I'm talking about is this. You have a module that starts with a module keyword. That's how you create a module. You have a module keyword and then the name of the module and the source where that module is within either your local file system or on a Git repository. So you can provide your local path or a remote URL. It could be essentially any URL. It could be a link to GitHub or even Bitbucket or even other source control repositories, or just an HTTP URL. So within a module, you specify certain input variables, like apart from the source, you specify, say, the project and the region. And this really depends on what you are trying to achieve. So if your module needs certain input variables, like a name, you can pass those input variables to the module within this module block. So what are some of the module best practices? It is important to have your modules in a Git repository, and I've already stated that that is for version control. You can be able to try certain versions and then test them before you use higher versions. You could have different version on staging and a different version on production. Very close to that is that you should semantically version your module. So you could have version 1.00, version 1.01, 1.02 in that order, and you can achieve that using Git tags. So whenever you push code to your Git repositories, you'd have maybe version 0.01, and whenever you make certain changes, you would promote that to version 1.02 in that particular order. And remember, whenever you want to roll back, you can bring back the version to 1.01. That is if something goes wrong. You can also, the good thing about having modules in your Git repository is that you can validate those changes via code reviews, because if a DevOps engineer pushes code to a Git repository, then that would go through a pull request. So a pull request will be made, and then the reviewer will merge those changes to the main branch. So that way, you make sure that any changes that you have made to your modules have been well tested, and as a code reviewer, You will go through that code and probably even test it before you merge to certain branches, and that way provides better security so that you don't push bugs into certain environments, whether on staging or production. Also, Terraform provides a module registry, so you could find a number of open source modules. You do not have to reinvent the wheel. So whenever you need certain modules, you could go to Terraform module registry. Let me just show you that right away. So you can see there are thousands of modules you can reuse within your infrastructure code. So you have modules for creating a VPC within AWS. You could have modules for creating VPCs within Google Cloud, and all that is provided within the Terraform module registry. So it's a good practice to reuse certain modules, some of these modules, instead of having to create a new module from scratch. So next, we've talked about that. The next question is, how do you write tests for your infrastructure code? The good thing about tests is that tests give you confidence that your code works as expected. So whichever tests you've written, you can be able to battle test some of those modules before committing them to the main branch. Some of the test strategies available out there, we have static analysis and unit tests. I'll not talk about integration and end-to-end tests. So first, I'll talk about static analysis. So static code analysis just means, having a dry run of your infrastructure code before actually deploying it. So you could achieve that either using Terraform plan or Terraform validate. So here you are trying to check whether the code has syntactical errors or whether it just runs as expected. So whenever you run Terraform plan, then you can review changes to your infrastructure before you actually deploy them. And this is the most basic level of testing, where you test the application, you test the infrastructure code without actually deploying it. So either using Terraform plan, you can be able to see changes that are going to be made on your infrastructure. So you'll be told this resource is going to be created, or the resource is going to be destroyed. So that way you can manually review changes to your infrastructure. But this is not the kind of test I'm talking about. So we want to be able to test the individual pieces within our application code. So that's where unit test comes in. So you test certain pieces of your code, and then you can be able to know whether or not those tests are going to pass. And if they pass, then they give you confidence that whatever has been tested is going to work well even in production. Yeah. So unit testing, as the name suggests, means testing individual modules. So you test, say, VPC module, and you could test a GCS, say a module for creating a GCS bucket individually, and then be able to run certain assertions, maybe to check if the bucket that you wanted to create is the same bucket that was created. And it's a little bit different from the tests in procedural programming languages, which always tend to interact with the internal environment. So say you are writing code, PHP, you're writing PHP tests, it is possible for you to even mock both the internal and the external environment. So most tests that you carry out in programming languages are essentially going to interact with the internal world. But the issue with the infrastructure code is you have to test real infrastructure deployments. So you will have to interact with the external world. So that would mean you will have to run Terraform plan, run Terraform apply, and probably even provision infrastructure within a test environment. So if you are doing that in a procedural language, it would look something like this. But if you're working with infrastructure code, you have to interact with the cloud providers. That way, if you would know that if I was provisioning a cloud instance, then you are sure that that test passes. You can be certain that those tests are going to pass if you can test those individual modules within your infrastructure code. So that would mean deploying it in a real environment. It could be GCP, it could be AWS, and so on. But we recommend that whenever you are running your tests, those tests run in a sandbox or a different project. You do not want running your tests within the same project on production or on staging. You want to make sure that those tests do not interfere or make changes to your different environments. So you'd have a different project if it's on GCP. If you're using AWS, then you set up a different AWS account. So the good thing with tests is that you can provision the test, validate that those tests are passing, and destroy that test, that infrastructure once the test completes. So every time you run a test, it will provision that particular module. It will run a few checks, maybe to make sure that those tests pass, including running certain assertions on the test. And then once that test has been set up, then you can destroy. And destruction happens whether or not the test succeeds or not. You do not want running tests and then certain errors are thrown, but it leaves traces of your infrastructure changes within a cloud environment like Google Cloud. You do not want technical debt. So with tools like TerraTest, you can run the test, validate those tests, and destroy or clean up that infrastructure once each of those tests pass or fail. So we could use tools like TerraTest, which is a library written in Go. You can also use Kitchen Terraform. And again, there are a lot of other test tools out there, but we use TerraTest in our company. I would want to discuss a little bit of that, but maybe before I talk about that, let me just discuss our directory structure. So you would have an environments folder. You could have the different environments like staging, QA or production, and then you have the examples folder where you have your individual modules kept in separate directories. And then you have a test directory where you'll write your tests in Go. So TerraTest is a Go library. So your unit tests will essentially be written in Go. So maybe just to take you through this first, you have maybe a test for provisioning cloud build. You would put that in a unit test.go. You'd have another unit test for creating a bucket. You would have another test for creating secret keys and all that. So all your tests will go in the test folder, and then you have the examples folder where you specify the individual modules that you wish to test. So it would have, say, a main TF and a variables TF. Variables to keep all your variables you're going to use for that test, and then the main TF will have the actual infrastructure code. I'm going to take you through that shortly. So this is the basic application structure. Let me just let me just show you that from my terminal. So let's see what we have. This terminal. So we have this test directory, and we also have the examples directory. So we'll go straight to the examples directory. So these examples, like I've said, represent the individual modules that you wish to test. So say you wanted to test the creation of build triggers within Google Cloud, then you'd put that code here. So you have a variables.tf where you specify the name of the project, the region, the branch, and so on. And then you have a main.tf where you will specify which version of Google you're going to use, region, and test service account credential. So that because you have placed your tests in a separate project, then you would get that service account credential and then be able to use it to authenticate requests to your Google to your cloud environment. So this is a sample module that creates a cloud build trigger on Google Cloud. So as I'd said earlier, you can specify a remote URL. It could be a GitHub URL or just an HTTP URL where your module has been hosted. So you can see that from here, I have hosted these modules on GitHub within the modules directory, cloud build, and then you can specify which version you want to test. So you could have certain versions, maybe from 1.00. You can roll back if you encounter any errors. And it's the same code. Even if you look at the KMS example, it is just the same. So you have a main.tf, it's the same boilerplate, and then this one has slightly different input variables. So you'd specify the name of the keyring, the name of the key, and then the source attribute, the source input variable will also specify the path to where those modules are hosted. The same thing you'd see here for secret manager. Again, you have your secrets that have been kept in an environment variable. As you can see, you can have an env file and then have your secrets, say Docker username, Docker password, and all that, SSH keys. You can be able to put that in a config file, which is here, and then you'd have your build secrets here. For this example, it's just Docker username is test. So you can be able to test. You can be able to keep those secrets within an env file. So also another test to create a VPC network, still the same thing. So you have the main TF, and then you have variables, and you have your TF vars. You can be able to pass different things like the CIDR block, the name of the network, subnetwork, and certain IP ranges. So I'm gonna try to run those tests. So I'll go to the test directory, and then just run go test. I can test cloud build test.go. Let me do that with a V option to be able to. So you are testing an individual module. So you make an API call. Terraform makes API call, certain bugs here, but this illustrates that you can be able to make certain calls to your provider and then run certain assertions to know whether or not the test is going to succeed or fail. So the same thing for secret manager and all that. You can run all the tests at once using just go test, this command will run all the tests across for all those modules that we have specified in the example folder. So that's pretty much about tests. I will hand over to Yunus, who will talk about a bit of GitOps and take us through the demo code. Over to you, Yunus.
Okay, so at our company, thank you, Basil, for that brief end-to-end introduction of every step that you go through while using Terraform.
Yeah.
For me, I would like to showcase the application end of why do we really need the infrastructure in the first place. So the whole idea for us having infrastructure is for us to run our application so that it can be used by our clients and customers. But with Terraform really describes the infrastructure configuration part, but there is also the application configuration part that we found in our company. It's better for us to separate the two and leverage the use of GitOps. So what really is GitOps, right? So GitOps takes DevOps practices and applies them to infrastructure automation. What really this means that the core idea behind GitOps is us having a Git repository that will contain the declarative description of our application configuration. Right? So we'll use things like Git, version control, configuration as code, and all that to implement CI/CD. Right? So infrastructure code can now be stored in Git repositories, reviewed, merged, and pushed to any target environment based on different Git branches. So basically, the way Git handles the whole Git flow is the developers pushes code to a specific Git repository. Let's say you have a payment service, you push code there. You create a pull request, merge it to master on maybe on merge or on push to a certain branch. It triggers an automated CI/CD pipeline. That changes will automatically be built, tested, and pushed to target environment infrastructure. And upon that push, that will trigger another our Git repository that handles application state, add the version and deploy our application in a CI/CD manner. So there are many benefits that we get when we implement GitOps. One such benefit is we can easily roll back because everything we now have a source of truth in that Git repository. We can track changes to infrastructure. Any change that happened to our application can easily go to the source of truth and know who pushed these changes, when, and what is the effect. And we can easily roll back in any commit. With that, we can also have faster and more frequent deployment. So whenever there's a feature has been complete, you can just push, and using GitOps what you just need is to push your changes to your code repositories, and that changes will be automatically be deployed in our environment through the use of GitOps. Yeah, and last but not least is the code review part. So yeah. So for us, we decided to use push push-based strategy, where through push, pipelines can react to triggers and a series of automated actions that I will try to showcase in the demo. Because of time, I'll just go through very fast, maybe to the demo part. So I will try to show you what really happens to, let's say you have an application that you want to, a new feature that you're building, like hello HashiTalk. So let's say this is like you've just finished developing your new feature and you want to ship it to the world. So after doing that, you just do a simple git add git commit. It's a good message. Best feature ever. And you push your feature. And just like that, by just the developer doing the normal things they do day to day. So the yeah. So so a trigger will be executed, and a different kind of steps will run. Where, for example, in this case, you log into Docker, build the image using a description that you've done in a Docker file somewhere that is within our repository, where it just builds the image. The image is built. We try to make Git, configure Git to use SSH keys, right? And then when the Git is ready, we just do Git. You clone the current repository, CD to it, check out to staging, and all that. Yeah, and from that, yeah. So this is basically the same things that you do locally, but only this time it's being automated in the pipeline. We have now our manifest files, where now that's where application configuration, application state is stored. From there, you pull that repository, and you write you CD inside that repository and write the changes that the version change that you just pushed for the image. Same, you add, commit, and push that as well. So from the small from the change that the developer did, the following will be. So as you can see here, this is our application that I pushed. It triggered this change. Went on and built the application, pushed that application to Docker Hub, took that version change and updated it into the Kubernetes manifest. So upon that change in the manifest, another set of pipeline that was done to update our application into our cluster. In this case, so our changes are being deployed right now. So the developer doesn't really know how the application is deployed. The developer will just add the change, add, commit, and push the changes, and the application will undergo that continuous integration, continuous delivery pipeline, and deploy the application automatically. Maybe. Yeah, and yes, and just like that, the application has been deployed. So we can as well go to our cluster. Let me try to access the cluster and see the changes. I don't know if this is similar. Yeah, so we can check the we have a ports. Yes, and we can see our change has been deployed just like that. Yeah, I think that's it for me. Maybe I can take this back to my colleague Basil to finalize.
Okay, thank you, Yunus, for that presentation. I hope you can still hear me.
Yes, yes.
Yeah, so I know we've taken a bit of time, especially in the introductory stages, but I think that's all for us. Our code and these slides will be available. We've already shared that with the HashiTalks user groups. So you can always access these slides and the module repositories, as well as the application and infrastructure code. So that's all for us. Thank you, Hashi, for giving us this time to present. And yeah, we're happy that we've been part of this. Thank you. Thank you, guys. Yunus?
Yes, thank you very much, everyone.
Okay, that's all for now.
Thank you very, very much, Yunus and Basil, for this exhaustive talk. We appreciate your time, and we've come to the end of this particular HashiTalks. Rob, do you want to take over from there?
Yeah, sure. So yeah, I mean, we've given you some bonus content here. We've gone a bit longer, so I hope that you enjoyed that. I hope you appreciated that. I thoroughly enjoyed it. I always enjoy HashiTalks, and it just seems to get better and better every single year. We have a bunch of regional HashiTalks coming up throughout the year. If you just head over to the website, you can look at the schedule, and they tend to be held in native tongue. Obviously, in Africa, we have many languages, so English is the common denominator. But if you speak any other languages, the chances are there is a HashiTalks for that region. So check that out on the site. So put that on the screen. But yeah, how's your first experience been emceeing this, Alori?
It was very exciting. I liked the talks. It was, an enjoyable moment for me. This is something that I'd love to do, regularly, both in person, of course, and virtually. So thank you for the opportunity. Thanks to Alexandra as well and Jasmine.
Absolutely. Well, thank you for being here. Like this doesn't happen without you. And like you say, there's a lot of people behind the scenes that you haven't heard from or seen who made this possible. Me, I just turn up and do my best, but there's a lot of hard work that's happened months and months before by others. So thank you to the entire team behind the scenes. With that, we wish you farewell and enjoy the rest of your day. And thank you so much for listening to us.
Bye, everybody.